Hello, welcome to another stream. How about that? The last stream of the year. The last stream of the year. I bet you thought it's not gonna be the last one, but it is in fact the last one of the year. How about that? Yes. Welcome to the last stream. And today is Thursday, right? And today we are starting a new series where we're gonna be solving previous advent of codes. That's what we're doing today. Right, so we already solved Advent of Code 2020. It was fun. I really enjoyed it. So I want to enjoy it more. And we're going to be solving the archive of Advent of Code, but we're going to solve them in reversed order. So we're going to solve 2019, then 2018, 17, 16, and then 15, and even no 14, because it started in 2015. The reason why I'm going in an opposite order is because I heard that over time Advent of Code becomes worse and worse, right? So the idea is to go in the opposite order and experience how Advent of Code becomes better and better over time. Yes. So, and throughout the Advent of Codes, throughout the different years of Advent of Codes, we're gonna be doing different challenges, right? Like we did for 2020. For 2020, we did 25 different languages challenge, and the challenge of 2019 is gonna be solving all of the problems in Haskell, right? No matter how difficult the problem are, no matter how much the problem requires of the stateful code, it has to be solved in Haskell, no matter what. And that's pretty much planned for today. We're gonna just start doing that. How about that? Hello everyone, by the way. Hello Raguil, Mr. Botka, 07001, Cerimon, Unref, Harshit Joshi, NerdBHU, Heotzenbots, Kershe, Gailolo, Matigog, Keith Zor, Lindra Braga, NSBRN? Yes, NSBRN. Ronak Method V, as in Grim, hello. Smertos, Good Duke, Repatch 123, Rago, Lazy Greed, hello, welcome. Alright, so I already prepared right before the stream and made myself some tea. So I don't have to go to the kitchen, you don't have to wait for me or anything like that. Nobody's gonna get banned today for, closing the tab. Well, at least right now. Maybe later somebody's gonna get banned for that. So yeah, let's get started. Alright, so I'm gonna open the Chromium. And we're gonna go to the Advent of Code, but not 2020. No. Not 2020. 2019. How about that? That's the Advent of Code we're going to. And it's kind of cool that we don't have to wait for like the problems being unlocked. They already all unlocked. But unfortunately we cannot get on the leaderboard because we're kind of late to the party, like a little bit, just a little bit late. A few thermoses ready for the stream. I used to do that, by the way, Lazy Grid. I don't know how old of a viewer you are, but I used to actually making like thermoses of tea before the stream. I don't do that anymore because I don't drink that much tea anymore. So yeah, that was interesting. Okay, so let me see. Smertos is, holy shit, what the fuck is going on? I didn't even start yet and people already throwing money at me. Smertos is giving 10 tier 1 subs to the Zozin community. Thank you so much for throwing money at me and making 9 buffs Stop Gaming 50, Oi Songs, Chico Codes, Merlin Fry, Beme, Nerdy Beach 1, Big Reaper, Hardy 7cc. Welcome to our epic Advent of Code Club. That's right. We are Advent of Coders here. So, I have no idea what that's supposed to mean, but I assume that as we solve more and more problems, the picture is gonna unlock more and more, and that's kind of the theme of Advent of Code, I suppose. Have a good one and Happy New Year. Thank you so much. Happy New Year to you too. All right, let's do a little bit of a TSMR. How about that? How about that? That's a very noisy one, actually. I didn't expect that. It's kind of interesting. And the last drop. The last drop. Nice. Finally, I have a pretty strong cup of tea. It's so strong, it looks like coffee. But yeah, I just keep oversteeping the tea. That's why it looks like coffee. In fact, it is not a coffee. Okay, so before we're gonna go into all of that, I think we need to create a separate repo for all of our Advent of Code adventures. So people sort of keep, some people keep the solutions, all of the Advent of Code solutions in the same repo. I don't know, I kind of want to separate them in different repos for some reason. So maybe if it's not going to work out, maybe I'm going to merge that into a single repo, but I think a single repo per year sounds good enough. Also, it's easy to Google and stuff like that. Hello, Initial Second, welcome. Hello everyone who just joined. Alright, so let's create the repo AOC 2019. There we go. Alrighty. I cannot even just... yeah. The completion stopped working for me. And we're gonna create a folder 01 where we're gonna start developing the thing. How about that? Alright, so I'm gonna assume that it follows the same format, right? It follows the same format, and you basically have an input file, you have two parts, and the second part screws up your solution for the part one, and so on and so forth. So this is exactly what we're gonna try to expect. So it's gonna be main.hs, and yeah, it's gonna be main equal and define. Does anyone remember how to write hello world in Haskell? Because I don't remember. I think this is how you do that. I haven't programmed in Haskell for quite some time already. So main where? Yeah, if I remember correctly, first you have to declare the module, then you define an entry point, and then you just print hello world. It's as simple as that. So after that, we don't even need to compile anything. We can just use Haskell mode. Let's just wait a little bit. For some reason, Haskell mode, like for the first try, it loads up very slowly. You can even notice that in my latest Haskell video on my YouTube channel, by the way. If you never heard about my YouTube channel, I really recommend to check it out. It's my first one. What is my second channel? Actually, I have two YouTube channels. Actually, I have 3 YouTube channels. So, first of all, I have a personal YouTube channel called Alexei Kutepov, which is like I put just some personal stuff there, not related to programming sometimes, quite often not related to programming. Then I have a Tsoding channel, which is related to everything I do for the Tsoding project. And there is a Tsoding Watts channel, so I have 3 YouTube channels. So, yeah. Anyways. It seems to be working, and if I try to run main, it says hello world. As you can see, it says hello world, and I will probably need to maybe parse command line arguments at some point, and this can be done at using system environment, I think. Yeah. And that thing gives you command line arguments. But since we're gonna do everything in an interactive environment, maybe we don't need command line arguments. Okay, so let's actually go ahead and read the first problem. Can someone link to his personal channel? You can go to my YouTube channel, and I think in the tab of recommended channels, like there's a tab channels, you can find my personal one. There's nothing particularly interesting there, so Yeah, but I have a video that has 1,700,000 views there. You can watch it, I guess. It's like the biggest video I've ever done in my entire life. It's almost 2 million views, so it's kind of cool. And I did it completely myself, believe it or not. Believe it or not. Okay, first problem. The tyranny of the rocket equation. Santa has become stranded at the edge of the solar system. Oh no! While delivering presents to other planets. Holy shit. To accurately calculate his position in space, safely align his warp drive and return to Earth in time. Is the music too loud? I don't think so. To save the Christmas, he needs you, to bring him measurements for 50 stars. Collect stars by solving puzzles. 2 puzzles will be made available on each day. Except 25th one, because on 25th day you get 1 puzzle. Right. The second puzzle is unlocked when you complete the first one. Each puzzle grants 1 star. Good luck. The elves quickly load you into spacecraft and prepare to launch. At first, go/no-go poll. That's pretty strange. At the first go/no-go poll, every elf is go until the fuel counter upper. They haven't determined the amount of fuel required yet. I have no idea what that sentence means, literally. Are they talking about Go programming language? Are they trying to decide whether to use Go or no Go? Are they discussing polling versus like asynchronous? I have no idea. Fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3, round down, and subtract 2. You could have... Okay, so they wrote the mathematical formula using natural language. Classic. So Advent of Code in the previous year already done something similar. They wrote a code in natural language, so you had to follow natural language and you reconstruct the code and shit like that. Classic. But this year is supposed to be better than the 2020, so I have really high hopes. For example, for a mass of 12, divide by 3 and round down to get 4, then subtract 2 to get 2. For mass of 14, dividing... okay, cool. The fuel counter upper needs to know the total fuel requirements. To find it, individually calculate the fuel needed for the mass for each module you puzzle. Really? So essentially, you have to iterate through each number in your puzzle input and apply this silly formula and just sum everything up. Okay. I mean, it's the first day, right? What did they expect on the first day, am I right? So obviously, like, day 10 is gonna fuck me in the ass pretty hard, but this one is sort of like a warm-up. And by the way, since there's no spoilers or anything like that, we're gonna solve several days per stream, right? Unless we hit some difficult problems, and in that case we're gonna actually solve them for 5 hours as we did in 2020, am I right? Another 25 days experience with 5. No, this time we're doing Haskell, right? And in Haskell there is no side effect, so you cannot read from files. Anyway, so so this time I'm not gonna waste any time or resources on learning how to use language, because I'm using Haskell. I already wasted enough of my life learning it. So let's go. So the fuel counter, the mass. All right. So maybe I'm gonna just take the puzzle input and put it somewhere here. So here's the puzzle input. Cool. And next thing we can do, chat, we can try to read the file, right? So if you try to read the file, this is the shit you will get, essentially the shit you will get. So the next thing you can do, you can split it by lines, right? And you got the specific separate lines, right? The next thing you can do, you can try to convert it to integers, right? You can try to convert them to integers. And I think this is how we have to do that, because we cannot specify the types or something like that. It's not like this. I forgot. What does it have to do? What does it have to do? Oh, it has to be mapped. Yes, yes, yes. There we go. So here is our input. Believe it or not, this is our entire input. And what I can do with that input, I can sum it up. And here is the whole sum. Isn't that epic? Isn't that epic? I think it's pretty epic. So what's funny is that I think I already mentioned that thing in one of my videos. We can use type applications, I think. I keep forgetting how it's called. I think it's type applications. Yeah. And then do something like this, and there we go. Isn't that epic? I think it's pretty good. So, and but that's not enough actually. That's not enough, because you also have to apply that silly formula that they give you. You have to divide by 3 and round down to get 4. Right, how can you do that? You might think that the easiest way to do that is to actually, you know, literally like divide by 3, something like this, and you know, maybe let's actually do it like this. What if I divide it by 7, right? And round down using floor or anything. But to be fair, you don't really have to do that, because you can just literally use integer division and it automatically rounds everything down. You don't have to worry about that. So this is computer science 101 for you, boys and girls. For those who didn't know, Haskell seems more like doing a math proof. Yeah, you probably never done a math proof. So let's continue. So this is essentially what we need to do here. We need to divide by 3 and then subtract 2. Okay, so and if we try to do that, right, 3 and then I subtract 2, and what do I get? I get 2. I'm not sure if I have to actually wrap it in parentheses. Jesus fucking Christ, my neighbors are going crazy. Oh, today is a new year. It's actually 31st December, so oh, I won't be able to sleep today. Holy fuck. Well, I mean, my sleeping schedule is ruined anyway, so okay, so essentially what we need to do, we need to turn this into a function that is capable of doing this, right? That is capable of doing this, where I can just apply this function to 12, and there you go. But I think we can kind of simplify this situation, right? So essentially, you can turn it into a composition of 2 functions. Oh shit, I think you have to be a little bit more careful, yeah. Yeah, there we go. So this is what I call Haskell. Who fucking needs any of this shit? This is Haskell. So essentially, who understands what the fuck is this shit? So I partially applied div and I partially applied minus. And then I composed them together to form a new function which basically does that. But okay, I'm not gonna do that, and it even calculates everything incorrectly, I think. Yeah, it even calculates everything incorrectly. Okay, we're not gonna do that, we're gonna use this function then. Anyways, so we're gonna take our original shit, and we're gonna map, before summing anything up, we're gonna map it with this silly formula, and this is the result we've got. This is the result we've got, and let's see. First try, motherfucker, without even writing any single line of code. I did everything from repo. Fucking everything from repo. One-liner, first try, got cooler. How about that? I mean, it was first day. I mean, first day is supposed to be actually easy. Anyway. So maybe we want to save all of that to some sort of like a variable or whatever. So this is gonna be part 1, believe it or not. So this is gonna be part 1. The type of part 1 is gonna be IO integer, and I think it can just oh, by the way, since we don't since we already provide the return type, we don't need type application, so that's actually pretty cool. And everything compiles. So now part 1 gives us that. Cool. Part 2. let's read about part 2. Holy shit, this thing like around here actually scared me a little bit, but yeah, we'll see. During the second go, no-go pool, the elf in charge of the rocket equation double checker stops the launch sequence. Apparently, you forgot to include additional fuel for the fuel you just added. Fuel itself requires fuel just like a module. Fuel itself requires fuel itself just like a module. Okay, so to transfer, like to move fuel, you also need fuel. You need I see what I mean. Take its mass, divide by 3, round down and subtract 2. However, that fuel also requires fuel, and that fuel requires fuel, and so on. Any mass that would require negative fuel would instead be treated as if it requires 0 fuel. The remaining mass, if any, is instead handled by wishing really hard, which has no... Any mass that would require negative fuel should instead be treated as if it requires 0 fuel. The remaining mass, if any, is instead handled by wishing really hard, which has no mass and is outside the scope of this calculation. Okay, it's day first, by the way. I'm already treated with this. So for each module mass, calculate its fuel and add it to total. Then treat the fuel amount you just calculated as the input mass and repeat the process, continuing until fuel requirement is 0 or negative. For example, okay, module of 14 requires 2 fuel. This fuel requires no further fuel. At first, module of mass requires this fuel, then the fuel, more fuel, and then you end up with this shit. I think I understand. Yeah, so I think I understand what is going on. So we have a module, it requires this fuel. And fuel itself also requires fuel, and you basically have a recursive formula that, you know, generates the sum, and you just sum everything up. So should be pretty straightforward, right? What's the sum of the fuel requirements for all of the modules on your spacecraft when also taking into account the mass of the added fuel? Calculate the fuel requirements for each module separately, then add them all up at the end. Okay, are you guys ready? Are you guys ready to implement this beautiful requirement? So essentially, it's the same formula, right? It's the same formula, but you have to repeat it for the result as well. You have to repeat it for the result as well. So the total is 2. Ignoring laws of thermodynamics by rounding down. Exactly. Alright, so let's implement a function that will calculate fuel. Fuel, we're gonna call it rec, because it's a recursive function, right? It's a fuel rec. It's gonna accept an integer, and it's gonna return an integer. And so if you try to calculate a fuel for something like 0, right? You're gonna get 0, which makes sense. But again, this doesn't account for negative situations, right? It doesn't account for negative situations, so maybe it would be better to use some sort of like a condition guards, right? So here is the mass, and if mass is less or equal than 0, then we return 0. 0 fuel is required for this kind of shit. Otherwise, so what we're gonna put here, okay. We will have to use fuel rec. No, we'll have to calculate the following thing. So first we'll have to calculate how much fuel required for this particular mass, and we can do that by using this formula. Hello Chistikot, welcome to the stream. Lambda community, what is a Lambda community? Never heard of them. Is that like people who wait for Half-Life 3? Is that the Lambda community? Okay, so you have that shit, right? And what you're essentially doing here is you take that mass and you calculate fuel requirements for that mass as well. And this is how you make this shit recurse. You see what I mean? You see what I mean, chat? Isn't that epic? I think it's pretty goddamn epic. All right. So, and that's the whole thing. The only thing we need to do here is to test if this works or not. So fuel, type of the fuel rec. Fuel rec. So what about 14? So 14 has to be 2. It's 0, everyone. Nice. I wonder why. So if I divide 14 by 3, right, it gives me 4. Then I do -2. It gives me 2, right? And then, like, I take 2, and then I try to calculate this thing for that, right? So I should get, I think, at the end, you know, 2, at least 2, because that recursive thing, like doing fuel rec for 2 will give me -2. That's very interesting. So that means if I do, I think 2 divide by 3, right? And you have to, okay, so we have to be a little bit careful. If I suppose we have to pre-calculate this entire thing. I think we have to pre-calculate this entire thing first. So and again, maybe I'm gonna put it somewhere here, right? Maybe I'm gonna put it somewhere here. So then, didn't the problem say the negative fuel should be treated as 0? That's not my problem. My problem is completely different. You misunderstanding the problem. Okay, so here is this thing. So mass, and this is a fuel, and yeah, n less than 0 has to be 0. If it's positive or something, right? Otherwise, it has to be something like n plus fuel rec n. And I think this is a better solution, right? Because we're looking at that, and I think it's a better solution. I think it's a better solution. Let's see if it's gonna work. So it's a fuel rec 14, and it gives us 2. For 2, it gives us 0. 14, cool. Now 1969. Yes. Funny sex number. So funny. Holy shit. 1969. And what do we get at the end? 966. About that, 966. Would you look at that? And we can take a look at another one. 10, 10, 7, 5, 6, 7, 5, 6. This is a 5, 3. There we go. It calculates everything correctly. So what is the sum of the fuel requirement for all of the modules? Cool. So essentially, part 2 is this, but with this function replaced. Okay, let's actually call this function not fuel rec, but rather fuel 2. And we're gonna have something like fuel 1. Right, in fuel 1, we're gonna have, let's put it like that, and I'm gonna put it like this. 10, boom, fuel 1 takes an integer and returns an integer. There we go. So instead of part 1, what we're gonna have here, we're gonna have a function called solve, right? And it's gonna be parameterized by the fuel function, right? It's gonna be parameterized by the fuel function, and the fuel function is this, right? I don't know, we can even create a type fuel, right? Which is the function from this to this, and then we can abstract everything away here, right? So it looks a little bit nicer, it looks a little bit better, and then we can do something like this. And furthermore, you have 2 consequent maps, which means we can squash them into a single map like this. It looks even better now. So now we have solution for first one and for second one just by using different fuel functions, and the solution actually has the same structure. You can just basically parameterize it with different things. So you can do solve fuel 1, which gives you the previous solution that we confirmed is correct. So here it is. And here's the second solution. So, and hopefully that one will give us a first try as well. Are you guys ready? Are you guys ready? Boom! First try got cooler. How about that? Isn't that it? I think it's pretty epic. Cool. So look at that solution. Look at that solution. Isn't that amazing? I think it's super cool. I think it's super cool. All right. So maybe we need to actually turn it into like something that looks nice. I don't know. Using printfs and shit. Type. It's not type. Import print text printf. Printf part 1, right? Part 1, and it's gonna be just function solve fuel. This one is interesting because solve, right? Solve requires produces a side effect, right? It produces a side effect. So that's very interesting. Maybe we could extract the input reading from the solve function, so the solve function can only focus on solving the input. So we're basically trying to separate dirty and clean code, like pure and impure code. So, and how we're gonna do that? So solve is gonna accept the fuel function and a list of integers and produce a single integer without any IO bullshit. How about that? So, and essentially, the whole thing is gonna be map fuel sum. And yeah, that's pretty much it. Map fuel sum, and we don't even need to accept the second parameter. So, and we can do the following thing. Input is going to be a read file like this. Split everything by lines. Split everything by lines. Read everything, and then we do solve fuel 1 input. Right, solve fuel 1 input. Solve fuel 2 input. The second part. There we go. So yeah, it became even more clear, concise, decoupled, and everything. So we have a perfect code reusability. Thrash5, welcome to the streamers. How are we doing? And it doesn't even compile because I forgot to do input txt. So now if I try to do main and I forgot a new line, classic. Classic. Main, part 1, part 2, there we go. How about that? Cheers. So, I don't really know if we need to do any documentation here. Should be pretty straightforward because like all of the solutions probably need to be run in a similar way. But yeah, we can at least put a readme here, saying something like day 1, and we can point to the day 1, right? So here we go, day 1, solution. Well, we're not going to say in Haskell because all of the solutions in Haskell. And the only thing I'm going to put here is expected result, and it's going to be console. And let's go to the Haskell part, and this is exactly what we expect here. So part 1, part 2, boom. Okay, now I also want to add global readme, kind of similar to the one that I had for AOC 2020. Yeah, explaining like what the fuck is going on. Solution for Advent of Code 2020 from Zozin. Yep, and it's gonna be 2019, and close that, so link to that one. Cool. So what we're gonna put here, I also want to put quick start, essentially console cd day folder, and within that folder run ghc main hc. So basically it's going to be the same way of running for every day because we're using only Haskell. Hello Nutrix Live, welcome to the stream. don't listen to the chat. Weebs are welcome, non-weebs are welcome, everyone is welcome to this chat, as long as you subscribe to me. People think that you're a hacker, can I hire you? No and no. Both of the statements. I'm not a hacker, and unfortunately you cannot hire me, at least right now. So yeah. Mutual Assured Seduction, welcome. Really glad to see you all today. Alrighty, so let's save all of this shite, and let's turn this into a repo. So we're gonna do the following thing: git init. Can you hack my ex-GFS Facebook? I don't even have a Facebook. I don't even know how Facebook looks like. I'm not even joking, by the way. I never used Facebook in my entire life. It's true, we have nothing against weebs and non-weebs, exactly. Okay. So let's see. Add 01. Add day 1 solution. No, I also don't have a VK account. I don't use any social networks except GitHub. You may think that I have Twitter, but Twitter account, twitter.com/todding, is not my personal account. It's an account for the Todding project. So yeah, I personally just don't like to use any social networks, but I do have some social network for the Todding project, because that's what you do if you're a streamer, right? If you know what I mean. So I personally, the only social network that I use is GitHub and nothing else. Also Discord. Discord is not a social network. Okay. Let's create the repo. And that's why I like Discord, by the way. No TikTok. I have a secret OnlyFans. Okay. With the pictures of my dirty codes, but I'm not gonna tell you because you're not a subscriber. All right, AOC 2019, and so okay, Advent of Code 2019 solutions in Haskell. How about that? And by the way, I just realized that I forgot to add a license. Okay. So yeah, what's gonna be the license? MIT license. And we're gonna put everything here. There we go. And what's gonna be the year? Well, it's kind of interesting. The year is 2020, but we're solving Advent of Code to 2019. So there we go. So this is going to be the license. You can do whatever the fuck you want with this source code, as long as you credit me. A release under MIT license. And did we already add the remote? Did we already add the remote? So it's going to be origin. We're going to put it here, and this is going to be the default remote, which I'm going to be pushing. And chat, are you ready? I'm going to push it first try. Look at that. Fuck yeah. Push it first try. God coder. How about that? I bet you cannot do that first try. So we need to update the project folder, project thing. So you're welcome, Chisticot, I suppose. I don't know. It's kind of a like not my best video, I would say. So what do we have here? And source code. Yeah, there we go. Cool. Project has been updated. So now if you want to take the source code of this thing, you can do it like that. So do we need to update AOC? Do we even need AOC? We can actually add additional repo here, right? So essentially update CMD 2020 is going to be this 2020. Right. Then 2019 is going to be, guess what? It's actually kind of difficult to guess because we have a very inconsistent naming. So 2019 is that. You would never expect that it that. So let's update AOC. I forgot to say AOC here. And is it gonna look okay? Is it gonna look okay? I'm not sure if it's gonna look okay. It looks like shit. Anyway, whatever. So we solved first day, and we got this little thingy here. I have no idea what is that supposed to mean, but maybe that's a clue. Who knows? Who knows? Maybe it is a clue. So, okay, let's go to the folder 02 and create. This is not what I wanted. Main.hs, and it's going to be module mainware, undefined this thing, and yeah. So we're gonna use the same Haskell session. Cool. The second thingy. 1202 program alarm. I have no idea what that's supposed to mean, but okay. So they even have a link to 1202. On the way to your gravity assist. Okay. Gravity assist in orbital mechanics and aerospace engineering, a gravitational slingshot, gravity assist maneuver. Oh, I know what it is. Oh shit, I know what it is. I think I even, like, at some point a long time ago when I was a student, I even like wrote a simulation for this thing. Holy shit, it was so long time ago. So your ship computer beeps angrily about 1202 program alarm. So what's that? Thank you. On the radio, an elf is already explaining how to handle the situation. Don't worry, that's perfectly normal. The ship computer bursts into fires. Oh, it's probably a computer idiom. In computer engineering, hold and catch fire, known by assembly mnemonic HCF, is an idiom referring to a computer machine instruction that causes the computer's central CPU to cease meaningful operation, typically requiring a restart. It's kind of interesting. I heard Dennis saying this phrase multiple times, but I never knew that it's some sort of established idiom. But I mean, at the same time, it's a very old idiom. I don't think people use it that often these days, like especially younger developers. But it's kind of interesting. Now it makes sense because yeah, Dennis actually says this phrase from time to time, like hold, like in catch on fire or something. I think I remember him saying that. Okay, that's very educational. By the way, do we have HCF in NPM? HCF. HCF. There's a nice geeky TV show. I don't watch shows, I'm sorry. They require too much focus for me. Library written and provides an emulator assembly. Oh, it's even on topic. Holy fuck. So they created an assembly called HCF. Nice. Fuck, it's actually a perfect name for a virtual machine. But I already went with a different name. And it's already taken anyway, so but yeah, it's kind of cool. Maybe I should rename my hold instruction in virtual machine to HCF. I don't know. Alright, so you notify the elves that the computer's magic smoke, the magic smoke, if you know what I mean, is a humorous name for a caustic smoke produced by severe electrical overstress of electronic. Holy shit, like I never knew that these things existed? Wait a second. An actually educational advent of code? Holy fuck. Okay. You notify the devs that the computer's magic smoke seems to have escaped. That computer ran int code program like the gravity assist program it was working on. Surely there are enough spare parts up there to build a new int code computer. And an int code program is just a list of integers Yeah, thank you for providing the link to the integers. Yes. Thank you very much. It's pretty cool. Separated by commas, like 1, 0, 0, 3, 99. To run 1, start by looking at the first integer, called position 0. To run 1, start by looking at the first integer, called position 0. Here you will find an opcode either 1, 2, or 99. The opcode indicates what to do. For example, 99 means that the program is finished and should immediately halt. Didn't I implement that yesterday? Are we implementing a virtual machine? Speaking of VM project, when is the next episode coming? We're gonna continue working on virtual machine next week. So yeah, today is gonna be Advent of Code. Tomorrow we're gonna have a random topic. On weekend we're gonna have a game development, and after the game development we're gonna have another 3 days of virtual machine. So I'm planning to actually have like 3 days in a row of virtual machine every week. Then Advent of Code, then random topic, and then game development. So, but I haven't updated the schedule yet. All right. So you'll find an opcode. So program is finished and should encountering an unknown opcode means something went wrong. Yeah, it's basically Haskell BM. Opcode 1 adds together numbers read from 2 positions and stores the result in a 3rd position. This is literally what I did yesterday. The 3rd integer, the 3 integer immediately after the opcode tell you these 3 positions. The first 2 indicates the position from which you should read the input values, and the 3rd indicates the position at which the output should be stored. Okay, for example, if your opcode computer encounters 1, 10, 20, 30, it should read the values at position 10 and 20, add those values, and then override the value at position 30 with their sum. Okay, but then do I remove these values? How do I... Okay, whatever. Opcode 2 works exactly like opcode 1, except it multiplies the 2 inputs instead of adding them. Let me guess. Part 2. Oh no, apparently these opcodes mean something different. 1 is not a plus and 2 is not a multiplication. So did I guess it correctly? I think this is how it's gonna be. 4th! Holy fuck, hello 4th. Just execute it in BM. So it's completely compatible on the bytecode level with BM. I can just copy paste it and just run it in BM and it will give me the answer. Nice one. Okay. Opcode works exactly, multiplies the 2 inputs instead of adding them. Again, the 3 integers after the opcode indicates where the inputs and outputs are, not their values. Once you're done processing an opcode, move to the next one by stepping forward 4 positions. Okay, that makes sense. For example, suppose you have the following program. For the purpose of illustrations, here is the same program split into multiple lines. Okay, so this is like separate opcodes. Okay, so you execute that, and yeah, then you halt. The first 4 integers are at position 0, 1, 2, 3. Okay, together they represent the first opcode, 1 addition, the position of 2, blah blah blah. To handle this opcode, you first need to get the value at the input positions. Position 9 returns 30 and position 10 contains 40. Add these numbers together and get 70, then store this value at the output position. Okay, here the output position 3, blah blah blah. Why did they highlight at? Like, add these numbers together, then store these values at the output position. Here the output position 3, it at position 2, so it overrides itself. Oh, okay, so I see. All right. So basically, the program can modify itself. No spoilers. Mods, ban all of the spoilers. Permaban. Okay. Step forward 4 to reach the next opcode 2. This opcode works just like the previous, but it multiplies instead of adding. The inputs are at position 311. These positions contain 1750 respectively. Multiplying this produces 3500. This is stored at position 0. Okay. Stepping forward 4, more positions arise at opcode 99. Holding the program. There are the initial and final states of a few more smaller programs. Okay, cool. Once you have a working computer, the first step is to restore the gravity assist program, your puzzle input, to the 1102 program alarm state it had just before the last computer caught fire. To do this, before running the program, place position 1 with the value 12 and replace position 2 with the value 2. What value is left at position 0 after the program halts? What? I didn't understand the last paragraph. Okay. Once you have a working computer, the first step is to restore the gravity assist program state it had just before. To do this, before running the program, replace position 1 with the value 12 and replace position 2 with the value 2. What value is left at position 0 after the program halts? Alright, so I have to take the input, replace these two values, and then run it and look at the position 0. Is that? I solved few of this previously, but I didn't want to spoil it. Mods, ban everyone who spoils the problems. Like perma-ban, ban them completely from the internet, from all of my social networks, like from everywhere, and never let them even close to my channel, okay? The joke here is that I don't have any mods, okay? Calm down. So, it's a joke. Okay, so looks good. Looks good to me. Let's actually go and grab the input. Do you choose the language based on the problem, easier, faster, or do you choose the language as a challenge? Like, have you read the description of today's stream on the schedule? So we have a schedule page where we have a description of today's stream. So solving entirety of Advent of Code 20 in Haskell. No other languages is allowed, no matter how much stateful code the problem requires. So there's no language to choose here. So I don't choose a language. The language has been chosen and that's it. So, but the question is probably why did I choose Haskell before the challenge? Because I wanted to, it's not based on anything, right? All of my technical decisions on this channel are based literally on nothing. Don't expect them to be like well evaluated or anything like that. I just do that because I want to. Does it make sense? So yeah. If you're looking for the reasoning why did I do it this way, you're literally wasting your time. Oh my god, MCQ8 subscribed at tier 1. Holy fuck, thank you so much for 5 months of tier 1 subscription and welcome to our epic Opcode Club. Thank you so much. Thank you. So before we're gonna try to implement this shit, how about we make a cup of tea? What's your reward function? Amount of dopamine in my brain, I suppose. And I don't know how, like, what exactly releases dopamine in my head. Essentially, I just do things, and if they release dopamine in my head, I do them more. So this is my reward function. How it works, does it have a formal definition? Probably not. Do I care? No, I don't fucking care. Let's make a cup of tea. So does anyone have any questions, by the way? I just do things that make my brain go haha. Sorry. Imagine implementing this potentially, yeah. So, does anybody have any questions? For example, what kind of tea I'm drinking right now? I'm drinking Earl Grey, by the way. What time do you usually start streaming? An hour ago. You can check out our schedule. So check out our schedule page. It usually has like amount of time before the next stream. So every time you want to check out when is the next stream, you can just do that. Or you can basically go to this channel when I'm offline and type in the chat next. And it will tell you how much time like before the next stream, right? So this is how much time before the next stream. So just go to offline chat, don't be shy, type next, and you're not gonna get banned. You have to do it with exclamation. Oh my god. Oh my god, do I really have to explain such basic things? Okay. Oh my god. Seriously. Alright, let's make a cup of tea. Let's make a cup of tea. Does anyone have any other questions? Does anyone have any other questions? Have you tried drugs to activate the function? No. Majority of them are completely fucking illegal in the place where I live, so... And the things that are legal don't really release that much dopamine anyway, and only develop a dependency, so... no. Any opinion about ring language? I haven't heard about it. What the fuck is this shit? Next question. To be fluent in Twitch, you have to study at least 5 years. Okay, so I'm gonna go to the kitchen, turn on the kettle, don't go anywhere, or... fucking coming. I came. Hello. Alrighty. So let's start implementing this shit. The thing I want you to do, I want you to grab the input. Is that what you call an input? Okay. Let's grab the input. I mean, I don't judge. I don't judge. Sure. That's the input you want to work with. So let's try to parse this input. How can we parse it? It's actually easier to parse than the previous one. It's the same level of difficulty. So we can read the input file, right? We can read the input file. Right, and then... Oh, am I in the wrong place? I think I'm in the wrong place. Can I do quit? Yeah. Alright, so I think I need to do it like this. Is it reloading? I think it's trying to reload something. It's so easy to break Haskell mode in Emacs. It's amazing how easy it is to break it. Hello, cool wizard. How are you doing? Welcome to our epic stream. Some flags have not been recognized. Prompt 2. What is that supposed to mean? Can I just read the file, please? What if I restart Emacs? How about that? Maybe I just need to restart Emacs. I don't know. So I'm gonna go to this folder and just restart the Emacs. Can you Vim do that? Yes, exactly. Let's try to load this one more time. Maybe this time it's gonna work. Hopefully. Have you been doing Haskell a lot? No, I'm doing Haskell for the first time in my life. I know nothing about Haskell. Alright, so let's try to read the file. Right, it's gonna be input tx. This is not how you read the file. This is how you read the file. Look. Oh, okay. So you can't just split this entire thing by commas, because you don't have such function. You have function lines, but we don't really have a function that accepts a delimiter. And this is because we're using strings. Yes, this is because we're using strings. But as far as I know, if we used text instead of strings, we could use some splitting function. Let's actually try to import qualified data text as t, and maybe, but I don't need to do a cabal. Okay. All right, I think I should stop using Haskell mod. It's really not helping. Haskell mod is really not helping. I should stop using it. So essentially what we're gonna do here, we're gonna use a REPL, right? So in REPL it's a little bit easier, right? It's a little bit easier. You just open it like that, and there you go. So we'll also have to wait a little bit. I don't know why GHCI takes so much time to load anything. It's really strange. But what it does, it works, right? And we can now split things on a particular delimiter, right? On a particular delimiter. So I also want to import text IO as well, so I can do t read file and read the input, right? So just read the input. Then I can penetrate and do split on, and the delimiter is going to be comma. And would you look at that? Would you look at that? Isn't that amazing? So we split everything by comma, but the last element contains a new line, and I wonder if I can do another thing and, for example, map t strip each individual thing here. There we go. So we managed to strip this entire stuff, and afterwards I think we should be able to read it. Oh, by the way, my tea is ready. My tea is ready, so I need to go back to the kitchen, brew up the tea. Don't go anywhere, or you're gonna get banned. You know what's gonna happen. You know what's gonna happen. Don't go anywhere. Coming. What's up? So let's just steep the tea a little bit. Just steep. Are we back in 2019? Yes. The year before Corona. Cool. So can you actually read from text? I don't really know. So how can you read the text? Yeah, it's a pretty good plan. I also like it. I'm really a bit hungry. Even though I ate right before the stream, I'm still a bit hungry. So text read. Oh yeah, we do have read, which is nice. So does it just have a read function? So does it have readers and stuff like that? You can do a rational, decimal, read a decimal integer. Okay, that's interesting. But to be fair, I just don't really want to spend too much time doing all of that. So what essentially I want to do, I want to just unpack that into a string. And once I have this as a string, I want to do something like this. And of course, I cannot do that because I don't have type applications enabled. So I will have to do something like type applications. There we go. And there we go. So now we have a list of these integers. How about that? We managed to read the input. But the problem with this thing, right, chat, is that we need a random access to these opcodes, right? We need a random access to all of that. And in Haskell lists, right, and it is a Haskell list. If you take a look at the type of this entire thing, it is a list, as you can see. It does not allow a random access, unfortunately. It allows only sequential access from left to right. And we need a data structure that supports a random access. So, and Haskell does provide a data structure that supports a random access O of 1 amortized, right? It's not really like a real O of 1, it's O of 1 amortized, but maybe that's sufficient enough for us. And I think it's located in a module called data array, right? So this is what it gives us. Let's take a look at the array. Array is a type, right, that is parameterized by a type of the index, right, by the type of the index and the type of the element. So it's kind of like a map actually. You can, as an indices, you can use not only integers, you can use something else, I think. Anything that implements IX interface, right? And let's take a look at what implements IX interface. Can you use, like, can you implement strings to be IX interface? You can use words, ordering, integer, int, char, boolean, and oh, you can even use tuples of these things, effectively implementing multi-dimensional arrays. Okay, like tuple of two indices could be an index too. Isn't that interesting? I think it's pretty goddamn interesting. And also unit is an index as well. I guess it's for empty arrays. But yeah, so I haven't used arrays that often. So yeah, it's gonna be a challenge for me. So it would be way easier to implement the solution for this problem in something like C, but it is a challenge. We're not allowed to use anything except Haskell. That's the deal. Like, no matter how much stateful code this problem requires, has to be done in Haskell. Do whatever the fuck you want, drink as much tea as you want, Haskell, until you lose all of your hair. All right, so I think my tea is ready. And yeah, let's actually pour the tea. Are you guys ready for a little bit of a TSMR? What's up, Nectar Zeus? How are we doing? Welcome to the streams. Haven't seen you before. Are you new to this channel? I think you're new to this channel. Welcome. Alright, so let's try to construct an array. Essentially, I want to kind of save this piece of code. I even was subbed once, but I'm mainly looking. Oh, okay, I see. Makes sense. Welcome, then. So here's going to be the input. And I'm going to import data array. I'm not sure if I need to import it as qualified. Maybe I should. But we'll see. So I'm gonna import this qualified, so it's easier for me to grab basically autocomplete the functions from that module. So I'm gonna call it as a. All right, let's reload everything. And in array, what do we have? Do we have from list? Interesting. So is it array? So what's the type of this function? I think it is. Okay, so if I remember correctly how this function works, it accepts the list of pairs index element, and also the range of indices and creates an array for you. Right, so range is actually super important. Without the range, it cannot do that for some reason. All right, so this is not what I wanted to do, but anyway. So here's the input, and we can calculate the length of that input, right? So with n. No, I don't want. Just remove that, please. Thank you. Haskell mode is really annoying. Okay. So here's the length of the input. Yeah. Input requires I/O. So that means I have to do something like this. Okay, so here's that. 145. So that means the range is going to be from 0 to n-1. So here's the range. Right. Then we have to provide the input itself. We need to provide the input itself. How are we going to do that? We need to take the input, right, and map it, actually zip it with I guess starting from 0, yeah, so zip it with something like that. So I'm gonna zip it like that, that gives us this, and then I'll have to construct an array out of that, and there you go, we constructed an array. So, yeah, let's actually put it into the file, so it's a little bit easier to work with all of that. So the strip unpack and so on and so forth. So essentially what I expect here is array that uses integers as an indices and integers as values, right? So that's what I expect here. So, and I'm gonna read this list into a separate variable. Then I'm gonna calculate the size of that list, right? And then I'm gonna try to generate that array. It's gonna be array starting from 0 to n-1, and then we're zipping all of that starting from 0 with the axis, and we are returning all of that out of the do notation. I did it again. It's a reflex. I cannot help it. I'm still using Haskell mode even though I'm not supposed to do that. It's really bad. So reflexes. This is, by the way, why I cannot escape Emacs. Because reflexes are so goddamn hard to change. Right, once you develop them, that's it. You cannot get rid of them. It's gonna be super hard to get rid of them. And it doesn't even compile because, yeah, expected type, actual type, array of these things. Oh yeah, this is because it has to be IO. Yeah, it has to be IO because we read all of that from the file. Yeah, we read all of that from the file, and there we go. So we have the input, and here is our input. It's read from the file, and it's in array. It is, in fact, an array. Okay, so once we have an array of all of these opcodes and stuff like that, we can start implementing the interpreter, right? So this is what we can start doing. Okay, so let's actually implement a single instruction, right? Let's try to implement like execution of a single instruction. Can we? Oh, it doesn't really work. But we can do something like this. Yeah, there we go. I wish it was maybe something like this. Not sure if it's gonna compile though. Yeah, I don't think you can do anything about that. Alright, so we're gonna have it as a step. So I wanna extract this type into an alias of some sort, because I'm gonna mention this thing quite often. I might as well call it state, right? This thing is gonna be some sort of a state. Is it really a state? Because it's more of a memory, right? Isn't it? Puzzle input. Restore the gravity program. Your puzzle input. Okay, so we can call it a program. I think it would make sense to call it a program. Let's call it a program. Okay, and what's interesting is that on top of having a program, you also have IP, right? You also have IP, basically current instruction pointer. So the actual state is program plus its instruction pointer. So maybe this is something that we also have to represent, I think. Because of that, it could be just called memory. Data, machine, and we can call it a memory. So it basically stores the memory, right? It stores the memory. And then we have IP, which stores the current thing here, right? Which stores the current thing. Doesn't really... excuse me. Oh, because I forgot to put this thing here. There we go. And also I want to do deriving show, so I can actually print the state of the machine. There we go. So a single step of the emulation accepts a machine and produces another machine. But how do we indicate that we halt? How do we indicate that we halt? Maybe we can also indicate that here, as we did with BM, by the way. Yeah, we can also indicate it here. So basically we'll have to apply this function until we get a machine that is halted. Which is actually pretty cool. Look. So imagine that you have this function, and maybe we need a machine. So I want to call it an input memory. And then maybe we're gonna have a machine, input machine, which is essentially machine that is defined using this memory. You know what I mean? I need to sip my tea. My brain is actually slowing down. How are you guys doing? My brain's slowing down, but this is actually a pretty cool idea. I like it. So, if you have a single step and you want to actually have an execution, right? You want to have an execution. Now, let's not go there. First, I want to implement something better. We need a function, make machine. It will accept memory and it will return you a new machine. Right. So it accepts a memory and essentially it just sets the IP to 0 and hold to false. Right. And sets hold to false. Yeah. So this is the machine that we're going to use here. So essentially I can do something like input memory, right? Input memory. So here's my input. And then I can make machine from that input. So here is machine, it has IP 0 and false. So I can try to step it, but since we have not, haven't implemented anything, you cannot step. Right, let's implement some instructions. How are we going to implement them? We need to detect the current opcode. How can we even detect a current opcode? We need to get a value at a particular index. If I remember correctly, you can do something like get. I think you have to use this operator. Yeah, I think you have to use this operator to actually get everything. And this is why you have to not import arrays as qualified. Yeah. I wonder if I can do things like that. So if I do input and I want to take the element at the position 0, will that it does work? Would you look at that? It does in fact work. Huh. That's pretty cool. That's pretty cool. So that means when we're stepping, I wanna switch upon the opcode, right? Right. And what kind of opcodes you're gonna have? You're gonna have one, which is not defined yet. Then you're gonna have 2. I wonder if it's okay. It's 2 undefined. And then you're gonna have 99 undefined. And in case of any other opcode, what you have to do, well, I mean, we can only throw an error, saying something like printf unknown opcode d at position D. So we want to actually be as descriptive as possible, because if something happens, we want to know where the shit hit the fan. You know what I mean? We want to know where exactly that happened. This is going to be IP machine. So, and this is going to be the machine, right? So, but where can we get the opcode? So the opcode is essentially memory of the machine at the IP of the machine. There we go. So that's how we do that. No guards, or you can use guards on cases. We don't need guards here. All right. So is it going to compile? Let's find out. It does not compile parse case. Oh, because it has to be in. Yeah. Okay, I think. Yeah. I think this is how we do that. I think you have to put bars on InnoCaml. Yeah, I think it's an OCaml thing. For some reason I thought that it's a Haskell thing, but in fact it's a OCaml thing. So this is the text printf, and let's go. And it compiles. Yeah, there we go. So basically we take the current opcode, and yeah, we just dispatch upon it. We just dispatch upon the opcode. After that, depending on what we're doing here, right? So in both of the opcodes 1 and 2, we have to take the next 3 elements, the next 3 values. So the first 2 are the operands. It's actually positions, right? The first 2 are the positions, to like from where to get the values. And the third one is the destination. So I think we can call them something like SRC, SRC1, and SRC2, and DST, right? Source 1, source 2, and the destination. Makes sense to me, makes sense to me. And the way we're gonna do that, we essentially take the memory of the machine and the IP of the machine, but do +1, because it's the next one. Then this is +2, and then this is +3. This is gonna be +3. There we go. Cool. Undefined. Come on. Oh, that's an interesting indentation, I was gonna say. That's an interesting indentation. So what I'm thinking, maybe I'm gonna extract memory machine to a separate variable, so it's gonna be a little bit shorter. But to be fair, yeah, it will be needed for reading purposes anyway, so it should be okay. Okay, so it's gonna be memory machine, so this is the opcode, and now everywhere I refer to a memory machine, I can just use mem, right? And there you go. To be fair, I kind of miss the identifier memory, so maybe because of that I have to call them get memory, get IP, and is halt, right? So it's a little bit easier for me. You know what I mean? You know what I mean? So in that way I can refer to this thing as memory here, and maybe to this thing as memory. This is a machine, and then I can get memory, and this can be just memory, and this is going to be get IP. So now I can destructurize this entire thing to just get IP of the machine, which means, by the way, that I can actually get all of this stuff by doing destructurization, actually pattern matching. So I can do machine, right? First is the memory, second one is IP, and the third one is the halt, right? The third one is the halt. What's interesting is that when you halt it, I think when you halt it, it doesn't really make much sense to do anything, so we can specifically handle the halted state, right? If you halt it, you just don't do anything. If you're not halted, we take the memory and IP, and we don't even need to destruct them anymore. You take the opcode, and in that opcode, you just do memory at IP +1, then memory at IP +2, then destination is a memory at IP +3. Would you look at how pretty all of that is? Look at how pretty all of that is. Isn't that amazing? Isn't that amazing? Everything is refactored and looks super pretty. Okay. So, but these are just sources and destinations and stuff like that. We want to get the values at these positions, which means we have to treat this value as an index as well, right? Like this. You see what I mean? So it has like a one layer of indirection. It's a one layer of indirection. So now this is not SRC anymore. This is like an actual value, A1 and A2. And what we have to do here, right? What we have to do here, we have to take these two values and sum them up. But we also have to write that sum into the destination position. And how can we even do that? I have no idea. Do we have like something like set? Or maybe there's something like update. I don't know. Maybe it's like this thing. I think it's this thing. /. Okay, you take an array, then list of pairs index value, and you get another array. I think what this thing does, it updates the elements with these indices with the corresponding elements, but I don't remember for sure. So we'll have to go to the Google and just read more about this thing. So yeah. So yeah, this is the real challenge, by the way. You see how difficult it is in Haskell to do any stateful thing. If you need something like an array, you just have to do all of these things, because Haskell is not really good for this kind of stuff. But some people may argue that, well, it's actually good, you just don't understand, you just have to get used to it, but I think those people are in denial. Stateful stuff in Haskell is difficult to do, period. And that's kind of the point of the challenge. But then they can say, but it is good for you. That means you cannot like shoot your leg or something. No, it makes development of the useful applications really hard. That's what it does. All right. So construct array identical to the. Okay, so I was right. It's construct array identical to that one. All right. So now what we're gonna do here? We're gonna take the memory, right, and we're gonna do this // So the index at which we want to update the value is going to be DST, and there you go. That should give us the new memory. That should give us the new memory. So after that, we need to construct a new machine, right? So I actually want to do something like this. It's going to be machine, right? And in that machine, I'm updating memory. So this is the new memory. Then I'm updating the IP. It's going to be IP plus 4, I think. 0, 1, 2, 3, 4. Okay, so that's going to be 4. And hold is not going to be updated. That's not particularly convenient, but okay, I'm going to accept that. So you know what? Since I know what functions I want from the data array, I'm going to remove this qualified import, and I'm going to query replace all of these prefixes. I'm going to remove all of these prefixes, and now it looks a little bit better. I think it does look a little bit better, so it's maybe a little bit readable if you know these operations. And what can I say, boys and girls? We successfully implemented the first opcode. Isn't that amazing? Isn't that amazing? I think it's goddamn fucking amazing, mate. So to implement the second opcode, we have to just copy paste this code. Believe it or not, we just copy paste this code, align everything properly so we can do something like this. And we need to replace one single operation here from plus to multiply. There you go. So this is what I call a reusable code, right? The code that you can literally copy paste, right? So you take that code and you reuse it. That's the perfect reusability. Cool. And the next thing. So the opcode 99, not even 69, god damn it, basically means that we have to halt, right? We have to halt. And how we're going to do that? We're just going to set halt to true without modifying the memory or IP or anything like that. We just set halt to true, and that is goddamn it. Rewriting BM in Haskell, yes, that's what we do. I don't know both. I don't know if you were looking, but if you were not, if you just joined, you missed so much stuff. Like, we started to solve 2019 Advent of Code, and I'm reading the second day, and I'm realizing more and more that, what the fuck, this is just a virtual machine that we implemented yesterday. So we're solving Advent of Code, and this is literally the problem. Yep. It's like the thing that I did yesterday. Almost. Yeah, almost. By the way, our challenge for Advent of Code 2019 is that all the problems has to be solved in Haskell. So that's the challenge. Yeah. And it's kind of painful to solve this specific problem in Haskell. But with arrays, with data arrays, I think it's okay. I would say it's okay. Okay. Same stream as yesterday, yeah. Reusing content. Recycled content. Okay, does it compile? Okay, it doesn't compile because... What I wanted to query replace here is actually something like this with nothing. There we go. Are you gonna compile now? And I forgot that true has to be capitalized. Variable true, not in the scope true. Wait, what? 41. I see. Okay. So, couldn't match function type machine, blah blah blah. So what's the line? 44. But error. So they expect me to return some sort of error. Oh yeah, I see what's going on. It's an old code. It's a very old code. And now, yeah, there we go. Everything compiles now. So now we have a function that steps machine. Right. So you have a machine at a particular state and it steps it. So let's actually like grab some smaller machines. Yeah. So do we have a sample? Yeah, let's take this sample. Let's take this sample and let's try to step debug it. Because our machine is ready, by the way. Believe it or not, our machine is ready. So we just need to step debug it. So I'm gonna have like sample 01 txt. We're gonna put this thing here somewhere. So this is gonna be our first sample. But I think I need to refactor a little bit the way we read the input. I want to have function that would code something like memory from file, where you would accept a file path, right? So we could customize this file path. So this is going to be file path. People already setting off the fireworks. Interesting. Well, I mean, the new year is pretty soon, and yeah. It's understandable. It's understandable. Okay. So file pass. New Year in Russia is actually very huge holiday, really huge celebration. So memory from file, and the thing I want to do here, I want to do something like machine from file, where you can provide the file path. Fireworks indoors. Why? Like, I mean, I didn't say that it was indoors. I mean, I have a window here, I looked out of the window and I said that people are setting off the fireworks, and I don't know how you came to that conclusion, but okay, no, they're not doing that indoors. Okay. Quarantine. Dude, we're talking about Russia. So, okay, for those who doesn't know, Russia is a magical place. It's a very magical place where no laws and no rules work. No matter what the fuck the government comes up with, nothing works ever. Yeah. Yeah, it's a very special place, not gonna lie. Okay, machine from file. So we need to read the memory from file, first of all. Memory from a file path. And then we're gonna return the machine. So it's going to be memory IP0, and it's not going to be halted, right? It's not going to be halted. And this is what I want to have here. So I want to be able to read the machine from a particular file. I can confirm that about Russia, yeah. Look, it's a monad. Yeah. Actually, the reason why I'm actually laughing a little bit is that because I actually imagined that happening, and it's not that, doesn't look that far from truth. I can imagine people doing that. So, yeah, thank you so much. Anyway, let's continue. Doing what? So, essentially, basically what Lembakota said is that some fucking alcoholic hobo was staying in front of the indoors to the building and was protecting the building from the corona, not letting anyone to get in. Well, while being, I suppose, drunk and stuff like that. And this is actually sounds very fucking Russian. I'm not gonna fucking lie. Imagine like a drunk hobo staying in front of the like entrance of your building and not letting you in to your apartment because, well, he's protecting the building from corona. So this is like, I'm telling you, this is a really Russian scene. Like you would see something like that in Russia. That's why I laugh, because it's pretty plausible. Sounds pretty plausible. Anyway, so okay. So what do we have here? Someone goes near the building boss. Alright. So we need to do machine from file. We need to read the machine, sample txt from the file, and here we go. We read the machine from file. Right, we're at the machine from file. So I can actually store the machine here, basically unwrapping the IO monet. Some people say that you can't unwrap IO monet. You can't unwrap IO monet. I'm gonna show you something cool. Look, look, look. So we have a machine, and if you take a look at the type of the machine, it's IO machine. But what you can do, you can just do something like that, a boom, and look at the type of X. You unwrapped IO monad without using unsafe perform. I didn't use unsafe perform IO. No. Where do you see unsafe perform IO? You just did that, and everything's okay. Well, maybe Ripple like implicitly like uses unsafe perform IO, but I like to think about it this way. So Ripple has an implicit do notation. That's the way I think about it. It's like, so every time you're like writing a line here, you're writing another line inside of a do block. That's why it sort of works like that. So yeah, this is how it kind of works. But also there's like a lot of hacks to make it work. Well, it seems to have a lot of hacks to make it work, but yeah. All right. So machine read like machine from file sample 0101 txt. So here's the machine, and this is the machine. Let's try to step that machine, right? Let's try to step that machine, and according to this thing, the fourth element should become 70. So 1, 2, 3, 4. The fourth one should become 70, I suppose. Yeah, I guess. All right. So let's do step. And look at that. It became 70. So we have a function that takes a machine and produces another machine with a new state. Isn't that amazing? I think it's goddamn amazing. So, and IP equal to 4. So that means if you step even more, one of the elements, yeah, this element becomes 3500, exactly as mentioned here. And if you step even more, it halts. It actually halts. So what's interesting, what we need to do, we need to execute everything until machine halts. Right, so that's what we need to do. How can we do that? We need to repeatedly apply step. But there is an easier way to do that. We have a function iterate, right? So which takes a function, some value, and repeatedly applies that function to that value, producing a list. So we're going to do iterate step machine, and we're going to take, let's say 10 first machines out of it. So here is 10 first machines. And what we can do here, instead, we can do something like drop while not is halt. So basically, it's gonna take this infinite list of machines, right? Infinite list of the states of the machines, and drop all of the machines that are not halted. Then you're gonna end up with a machine that is halted, and you just need to take the head of that machine, and there you go. You have a fully evaluated machine. So you can even take this line and turn it into a function, I suppose. So execute. Let's put it like this: execute. Accepts a machine. Returns another machine, so it just executes everything, and we're gonna put it like that, and there you go. We can even compose everything together like so. So iterate step, drop while not is halt, and then take the head of it, and there you go, you executed a machine. Pretty cool, not gonna lie. But can we execute the input? Input is actually quite huge. It's not that huge, but I mean, it's decent enough. So if we try to execute, will it even like go into the loop or something? I'm just thinking, should I try to modify the thing first? Okay, so before running the program, replace position 1 with value 12 and replace position 2 with value 2. What value is left here? Hello, Dikarki. Welcome to the stream. So we need a special function that prepares the machine. Or restore. Okay, let's call this function restore machine. Restore machine is gonna accept the machine, right? We're gonna just accept the machine. And basically do these separations. Replace position 1 with 12 and replace position 2 with 2. Luckily, with the array notation, we can do that in a single operation. So we can replace 1 with 12 and 2 with 2. Right, did I understand that correctly? I think I understood that correctly. 1 with 12, 2 with 2. So that's pretty cool. Now, I want to do something like part 1, where I would accept the file path of the file, right? The file path of the file. And that thing should return me the machine, right? It should return me the machine. And what we're going to do here, we're going to take the machine, file path, machine from file path. So here's the machine, which we can restore right away after we read it. Restore the machine. Then we can right away execute the machine. And we only need to return it, I suppose. So that means we don't even need to do notation here. We can just do it like that. Yeah, so essentially you read the machine from file, restore the machine and execute the machine. There we go, and you get the fully executed machine. And the next step is going to be actually getting value at position 0, I suppose. Yeah, we can do something like that. Essentially, we need to get the memory of that executed machine, right? We get the memory of that executed machine, and then we need to take a value at position 0. I think that should work. So we can do like yet another one-liner here. Yesu, kawaii desu. So I want to double check that input is correct. And does it even, it doesn't even compile. Mother flipper. This is because I'm an idiot. We're supposed to return an integer. Okay, it still doesn't compile. Yes, I see. ICPC. So it has to be machine memory. So we have to modify the memory of the machine. Zozin, why are you not using lenses? Stop wasting time and start using lenses. Come on, Zozin. What are you doing with your life? Machine. Okay, machine. It has to be a machine. Okay, now it compiles. Would you look at that, boys and girls? Would you look at that? Isn't that fucking epic? I think it's goddamn epic. So we have a function part 1, right? Here's a part 1, and it just accepts the file and will produce the result. Will we first try this problem? Okay, so I'm gonna take the input.txt. It's gonna be part 1. And here is the alleged result. Here's the alleged result. I'm gonna put that result here and pow! First try, motherfucker, got coded. How about that? In Haskell. Isn't that amazing? Isn't that amazing? I think it's goddamn amazing. Actual, like a virtual machine in Haskell. Very stateful one with arrays and shit. Yep. Cool, but this was part 1. It's a day 2. And how much time did I waste on the part 1? Holy shit, I'm so bad. But I mean, it's a challenge. It's supposed to be a challenge, right? Because it's Haskell, you know, difficult and stuff like that. Where's my list of excuses? Holy shit, that's a... Oh my god. Okay. Yeah, it was a part 1, believe it or not. I mean, in something like C, it would be just easy. But in Haskell, you have to do all this shit. Okay, good. The new computer seems to be working correctly. Keep it nearby during this mission. You'll probably use it again. Real int code computers support many more features than your new one. But we'll let you know what they are as you need them. Oh, wait a second. People say that there is a lot of code reusage throughout this advent of code. So essentially, throughout this advent of code, we're going to be evolving this virtual machine over time. Is that what it is? Is that what it is? That's actually... Oh shit, this is why there is such a gap between 2 and 99. Right, this is such a huge gap, because you're going to have more and more opcodes over time. Holy shit. Oh, by the way, I wonder if the changes introduced into the virtual machine are backward compatible. Are they backward compatible? So essentially, at the day 25, can I take the machine at the day 25 and still solve the day 2 with that virtual machine? Is that a thing? So it basically extends in a backward compatible manner. If it is, it's actually very awesome. So because in that case, I could just like pull it out into a separate module and just reuse this module throughout all of the days. They are, oh, holy shit, that's cool. Why didn't I participate in 2019 last year? This sounds like such a cool year. Holy fuck. It sounds already better than 2020, so like I don't know. That's why I said Haskell BM. Oh, I see. So it's literally Haskell BM. All right. That's actually very interesting. So maybe at some point we're gonna actually extract that into like a separate module and stuff like that. But we're gonna be doing Advent of Code 2019 throughout like several weeks. So we're only gonna be doing them on Thursdays. So we're gonna have enough time to refactor everything, prepare everything, and stuff like that. Okay. So part 2. However, your current priority should be to complete your gravity assist around the moon. For this mission to succeed, we should settle on some terminology for the parts you've already built. Int code program are given as a list of integers. Those values are used as the initial state of the computer's memory. Well, okay, I already called it memory. So I know a thing or two about virtual machines. When you run an int code program, make sure to start by initializing memory to the program's values. A position in memory is called an address. Well, makes sense, I suppose. We can even do something like, you know, type address int and just use address like this. Why not? Address, for example, the first value in memory is at address 0. Opcodes mark the beginning of the instructions. The values used immediately after an opcode, if any, are called instruction parameters. Okay, so they are not operands, they are parameters. Okay. For example, in the instruction 1, 2, 3, 4, 1 is an opcode and 2, 3, 4 are parameters. The instruction 99 contains only an opcode and has no parameters. Okay. The address of the current instruction is called instruction pointer. Well, yeah, I already called it like that. I know a thing or two about virtual machine terminology. After instruction finishes, the instruction pointer increases by the number of values in the instruction until you add more instruction to the computer. This is why 4, 1 opcode plus 3 parameters. Well, it was kind of obvious. I mean, come on. For add and multiply instructions, the whole instruction would increase the instruction pointer by 1, but it halts the program instead. With the terminology out of the way, we are ready to proceed to complete the gravity assist. You need to determine what pairs of input produces the output. Pairs of inputs. So the input. So the input is 1 and 2. Like the input is first two words of the memory. This output. The input should still be provided to the program by replacing the values at address 1, 2, just like before. In this program, the value placed in address 1 is called noun, and the god damn it. So 1 is a noun and 2 is a verb. It's a Apollo reference, right? Did I get it correctly? It's a Apollo reference because there was Apollo computer interface. Apollo computer interface. Yeah, there we go. Yeah, Apollo guidance computer. Like it's literally you input commands into it through like by providing 2 numbers. The first number is a noun, the second one is a verb. Yeah. Noun. So there was nouns. Okay. Partial list. Here it is. Partial list of numeric codes for verbs and nouns in Apollo guidance computer. But maybe it's not specifically Apollo thing, right? Maybe it's like a common interface of the time. Maybe like a lot of computers at the time were like interacted like this through like verbs and nouns and shit like that. Yep. Okay, each of the 2 values will be between. Oh my god, this is easy. This is fucking easy. You just iterate with n square and you just find the one that produces the value. Should be super easy. Once the program has halted, its output is available at address 0, also just like before. Each time you try a pair of inputs, make sure you first reset the computer's memory to the value. We don't have to do that. By the way, we don't have to do a reset because we are programming in a, pure functional programming language. Okay. So once you first reset the computer memory, your puzzle input. In other words, don't reuse the memory from a previous attempt. So it's kind of like, it's kind of interesting. Why are they? So this is essentially like giving away a solution. They're hinting that you can do that by brute force. Like, why are they doing that? Maybe this is because it's day 2. Immutable, yeah, I was looking for a word immutable. Find the input noun verb that cause the program to produce the output. This one, what is 100 multiplied by noun plus verb, for example. Okay, it's actually easy. Once you have this this computer, it's actually super easy in my opinion. All right. So instead of like restore machine, I think we're gonna do something like input. Provide input. Right, provide input, and we're gonna have a 12.2, and we're gonna accept a noun and a verb. Right, so this is gonna be noun and verb, and we're gonna put them here. So this is a noun, and this is a verb. There we go. So maybe we can even call it just input. Why not? There we go. And part 2. What's going to be part 2? Maybe I also want to extract this thing into something else. Input, let's call it output. So essentially you're going to provide verb and this thing, and you're going to take a machine and you're going to provide this thing. So essentially this is what we have here. It's a noun and verb, right? So this is a noun and verb, noun and verb, and the part 2 is essentially output 12.2, right? 12.2. So this is a part 1. This is a part 1, and machine from file. We also have to provide the machine. I see. So, and this is where we probably want to do it like that. Okay. Yeah, we want to do it like this. Cool, cool, cool. So we take the machine from file, and this is what we do here. And I want to see if I didn't fuck up. I did in fact fuck up. Where is the place of the fuck up? 53. Noun, verb. I see. So that means the. Oh, I see. What's the problem here? Cool. It compiles. We have a part 1, and if I do part 1 on the input file, right, on the input file, it's that, and that's exactly the thing that we expect here. Cool. So part 2 is going to be slightly different, right? Part 2, file path, IUint. So essentially, we're going to prepare the machine. We're going to read. Hello PowerShell. I would really ask you politely to speak English because majority of people don't speak Russian. So machine from file, right? So it's going to be machine from file, file path. So here is machine. So we're going to just brute force this mother flipper, right? So we're going to do noun. We're going to iterate all of the nouns here. So the nouns are from 0 to 99, right? Is it inclusive range? I think it is inclusive range. Yes. So, and another thing, we're going to be iterating verbs, right? So this is the verbs and stuff like that. I think, I don't quite remember, but can I do something like machine machine prime? I think this is what I want to do. I want to do to be fair, I need to store noun and verb. That causes the program to produce. Okay. Output noun verb for the machine, that is equal to my value, right? So we're looking specifically for this value, right? And this is where we produce this thing. It's going to be verb, noun, and verb. And what's interesting is that I'm going to do a head, and I'm going to just return it. So once we find the first one, we're going to stop the execution, and we're going to just return that. So this is how we can essentially brute force this entire thing, right? We're brute forcing verbs and nouns. And on top of that, we may essentially just right away calculate the required value like this. Yeah. So since the language is lazy, it's actually gonna stop at the first found value because you don't require any like the consequent value, so it will just stop right away. So, and that should work, I think that should work. Let's see if it compiles. It does in fact compiles. And let's do part 2. So we provide output and stuff like that. Part 2, input txt, and it took some time. Notice how it took some time. I wonder if it's a correct value. And first try, motherfucker. How about that? 2 first tries in a row. We actually had 4 first tries on today's stream. 4 first tries. How about that? Isn't that amazing? The power of Haskell. Yeah, I guess it's a power of Haskell, maybe. Maybe. Anyway, so, I mean, if it compiles, it works. Haha. Alright, so we need to clean everything up, I think. So we're gonna do the usual thing. Where we accept the input. So I wanna, so this is what we're gonna do here. I'm gonna have a machine. We're gonna read machine from file. I read machine from file. The machine is gonna be read from input txt. So in these functions, in my opinion, should accept machines instead of specific values here. So this one is going to be more of a, so this is just a machine. You can even do something like this. Yeah, so part 1 is just that. Then it could be like this, because it's completely pure, it doesn't require any side effects. This one is also going to be completely pure. So we take the machine from here, and we can do it like that. And there we go. Okay, so we read the machine, and we're gonna do printf yet again. Yeah, so we already do have a printf. Now show code reuse in HS. I think we already actually did a lot of code reuse here. Like we're reusing a lot of code between part 1 and part 2. Or you mean something like this? This is such a minor thing that I don't think it requires that much of a code reuse. But okay, so since you're a subscriber by Creeper, I'm gonna extract that to a separate, thing if you want to. It's gonna be printf part 1. It's gonna be D, and it's gonna be part 1 machine. Machine. Cool. Part 2 machine. Okay, let's see if it's gonna work. I'm gonna just rebuild everything, and I'm gonna take a look at main. And yeah, part 2 actually took too much time. Why does it take so much time? Why is it so slow? I wonder if this is because machine is super slow. Yeah, it could be something about like strictness here. I mean, like moving the core functionality to the modules. Dude, we don't have enough information to actually extract anything to the modules. We don't even know how we're gonna use all of that. Why everyone is trying to build an architecture without knowing what is required? Don't do that. This is like a recipe for disaster and over-engineering. Just pile the code into a spaghetti until the pattern emerges, and that gives you enough information on how you can decouple it and structure it. Like, you literally don't have enough information to do these kind of things. Happy New Year to you too. Happy New Year to you too. Right, it's just too early to do this like architectural stuff. We just don't have enough information. Just pile the code and then we'll see. So yeah, just pile the code. I wonder if we can speed it up somehow. Okay, Haskell strict arguments. I don't remember how to do that. What if the spaghetti turns out too tangled for patterns to emerge? Well, that may happen, but with time and experience, you actually start to identify patterns in the spaghetti. The opposite of the situation when you end up with an over-engineered mess that is impossible to change is actually worse than spaghetti, tell me, trust me. Seriously. Because the opposite is you end up with a structure that does what you don't want and what you don't need, and which is very difficult to modify. Spaghetti, on the other hand, well, it's kind of tangled, it's kind of mushy, it's kind of difficult, but you can sort of shape it around, you can make it do the things that you want. That monstrosity that you've built, before even knowing anything about the problem, like it's useless. That spaghetti is at least useful. You can do something with it, and you can start working at it piece by piece. You can start like, unentangle it piece by piece. So you know what I mean? Yeah. So where is the explicit strictness? So okay, can we make it explicitly strict somehow? Rule of thumb of strict annotation. Maybe there is iterate. Iterate that is strict. Do we have an iterate that is strict? Like iterate prime. Oh, we do. Oh shit, that's actually cool. Is a strict version of iterate. It ensures that the result of each application of force to weak had normal form before proceeding. Okay, so if we can take a look at the the current speed of the part 2. It's actually kind of slow. Iterate, and now if I try to do something like this, reload everything, and we don't have iterate because first we have to data a list, import it. Okay, and now if I try to run it. It didn't improve much. It didn't really improve much. Maybe within the step itself we also have to do some. Wait a second. Maybe we have to use like a strict arrays. Maybe that's another thing we have to do. Yeah, and of course we have to not forget to do these kind of things. Yeah. Data array. Data array. Where's the data array? I think that's where it is. Do we have strict, immutable, non-strict? What about how can I have strict ones? Is it possible to have strict arrays? Strict arrays. Haskell strict arrays. Where are these strict arrays? Strict ones. I feel like there's no strict ones. Strict inbox. Okay, so there's nothing much we can do. Okay. Nah, doesn't prove anything. Okay, so let's do a committee. Let's do a committee. So I'm gonna do a readme md. Day 2. Day 2 solution. Expected result is gonna be console. Hello. Back in time, exactly. So here's the expected result, part 1 and part 2. Cool. And are we ready to do a committee? And even maybe a push. Term, add day 2 solution. Hello, Roger Chauncey, welcome to the stream. Alright, so you can find the source code for these 2 solutions here, right? So we already have a separate repo for Advent of Code 2019. So that's pretty pogue, not gonna lie. That's pretty pogue. Don't forget to star it. I'm joking. So yeah, we have day 1 and day 2. And day 2 was actually interesting. I really enjoyed day 2. Okay, damn it, I didn't mean to close anything. Didn't mean to close anything. Okay, so let's go back to the advent of the calendar. Alright, so this thing is no longer has square brackets. Now it has like this single thingy. I don't know what's that supposed to mean. So let's jump into the day 3. Oh, by the way, why nobody tells me that I forget to update my title? Chat, every time I solve a problem, please remind me to update the title. So, yeah. Yeah. Okay, I updated already the day 3. Mod! Those in why you don't update it, I already updated the title. Yeah, I was solving day 1 for 2 hours. Yes, that's how bad it is. That's how bad I am. Alright, so day 3. Crossed wires. The gravity assist was successful, and you're well on your way to the Venus refueling station. Why not Uranus? Wait, are we gonna have a Uranus joke in this advent of code? Chat, please tell me if we're gonna have a Uranus joke. Please, if we're gonna have a Uranus joke, this is gonna be the best year of advent of code, and I'm gonna regret not participating. Spoilers are it could be a spoilers. Alright, so don't tell me anything then. Don't tell me anything. Alright, so because the space seems to be like Apollo thingy, Apollo space computer and stuff like that seems to be the top theme of this advent of code, which is actually kind of cool. The gravity assist was successful, and you're well on your way to the Venus refueling station. During the rush back on Earth, the fuel management system wasn't completely installed, so that's next to the priority list. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to a central port and extend outwards on the grid. You trace the path each wire takes as it leaves the central point, 1 wire per line of text, your puzzle input. So the wires twist and turn, but the 2 wires occasionally cross paths. To fix the circuit, you need to find the intersection point closest to the central point. What is the central point, by the way? Central port, okay. To fix the circuit, you need to find the intersection point closest to the central point. Because the wires are on the grid, use the Manhattan distance. Yeah, I know what it is. For this management. While the wires do technically cross right at the central port where they both start, this point does not count, nor does a wire count as crossing with itself. For example, if the first wire path is R8U5L5D3, then starting from the central port O, it goes right 8, up 5, left 5, and finally down 3. I see. Cool. So when you have like a bunch of that wires and you need to find their intersections and shit like that, then if the second wire path is this, it goes up 7, right 6, down, okay. These wires cross at 2 locations marked X, but the lower left one is closer to the central port. Its distance is 3 plus 3, okay, taxi cab distance. Here's a few more examples. Okay, what is the Manhattan distance from the central port to the closest intersection? It's kind of easy. Like, I mean, it's kind of a simple problem. What is the central port? I just don't realize. Central. Okay, a connection to a central port extends after you trace the path each. It doesn't really matter, probably. The central port doesn't really matter. Basically, you can treat the central port as 0, 0, and all of the wires extend from that central port. So yeah, it's essentially 0, 0. Yeah, okay. So kind of cool, kind of pog, not gonna lie. So we just need to implement all of this shit. So different intersections and shit. But intersecting with itself doesn't count. Intersecting with itself doesn't count. Right. Itself. While the wires do technically cross right at the center port where they cross start, the point does not count, nor does a wire count as crossing with itself. So, yeah. Do we really have to care about that? Do we really have to care about that? Maybe, I'm not sure. Before we go into solving this problem, I need to make a small break and pee. No, I'm not gonna Google anything, trust me. I'm not Googling anything. Small break is gonna be, I guess, 2 minutes. I guess it's gonna be 2 minutes. Right. It's kind of an interesting problem, especially in Haskell. Again, in something like C, it would be super easy. Yeah, definitely not Google. But in Haskell, it makes it kind of difficult because, again, you need a board and shit like that. But again, you can simulate a board with arrays, right? So because arrays accept indices, and pairs of indices could be also an index, which means I can have two-dimensional indices, and this is how I can achieve all of this. Sounds pretty pogue. Sounds pretty pogue. And essentially what I need to do, I need to just go through all of the wires, put them on a grid. It's actually a very small input. Would you look at that? Oh, we even have like 2 wires. There's literally only 2 of them. Okay. Cool. So let's do a small break. All right. Small break. You guys have fun. And yo, what's up? Welcome back. So let's try to solve this shit, I suppose. Let's try to solve it. So this is a day 3, and we just need a grid. So in grids in Haskell are kind of pain in the ass, not gonna lie, but I think we'll be able to solve that anyway, because we're epic coders. God coders. Okay, 03. So here's the input main.hs, and we're gonna have a module main where, and then main IO undefined. Cool. Let me actually exit this entire stuff, and I'm gonna go to the date 3. So here's the date 3, and we're gonna have GHCI. There we go. There we go. Cool. So we definitely need something like text, right? Because we're gonna split in everything by commas. Thank you, Taponiano. Happy New Year to you too. So is it New Year already at your location? Okay, so it's gonna be text, and we also need to import arrays. I think arrays are gonna be kind of useful. Maybe also lists, we'll see. So let me try to reload everything, and we can try to read the file. Oh, I need to also import IO and maybe read. Read is actually kind of useless, so we'll have to unpack it. Okay. Read file. So we're gonna read the file, and we're gonna look into the input. So I didn't read the file. People getting excited about counter reset. Counter reset of what? What are you talking about? I'm not sure what you're talking about. Is that like a New Year thing for normies or something? Okay, so there's like thousands of those things. That's very interesting. There's like thousands of them. What I'm thinking is that, do we really need a grid? Do we really need a grid? What we need to do, essentially, is just to find a pair, like this defines array of segments, right? This essentially just defines an array of segments, right? So what we need to do, we need to find two segments that intersect, and yeah, and like take that intersection and find the closest one. All right, so yeah, that's actually a better approach, which doesn't require any grids or any arrays, and it just depends on how many elements you have there, right? Are you coding a VM later? We're gonna do a VM next week on Monday, right? So tomorrow we're gonna have a random stream for a random topic that is unknown. Then on weekend we're gonna have a game development, and then virtual machine again. You can find all points in the grid which match the one line. I don't know what you mean. Anyway, so what I wanted to do. So I'm gonna go to that and that. Will the VM have GC? It could. We can try to implement GC for it. Why not? But GC is needed if you have a dynamic memory. Right. So right now we don't have any dynamic memory. But we plan to introduce something for allocating some memory at some point. And I don't see any problems trying to implement a garbage collector. Essentially, we can go the route D goes, right? So we can scan the memory and look for something that looks like a pointer, and if there are addresses that are not present in any of the places in the memory, we can just call them dead and just, you know, remove the memory. What about the VIP subscribers videos queue Fridays? I'm kind of done with them. I didn't like them anyway. All right, let's continue. So what I want you to do here, I want you to split on this and just calculate how many of these things I have. Right, so I have 301, actually, yeah, essentially we have 300 segments, right, 300 segments. And 300 by 300 is not that big of a number, right, it's actually a very small number. Yeah, and we essentially can just brute force this entire thing, right, we can brute force it. And should be pretty straightforward. I think you need a grid. There is no way otherwise. Thank you for sharing your thoughts. I really appreciate you sharing your thoughts. Cozy White Bear, hello. Welcome to the stream. All right. So essentially, we need a type for a segment, right? And we need a way to convert like a sequence of these things into a single segment, right? Into a sequence of segments, right? So this one is going to be very interesting. So what's funny is that all of these segments are orthogonal, right? They all are orthogonal. And maybe because of that, we shouldn't represent them as pair of coordinates, right? So the usual thing you can think of, you can have something like a point where you have a pair of coordinates, right? So this is the point. And then you can have a segment. You can have a segment which is a pair of points. So essentially, at the end of the day, you have four numbers, like x1, y1, x2, y2. But what's interesting is that, as already mentioned, the segments that we're talking about, they're orthogonal. They are either horizontal or vertical, right? So, but this type representation gives too much freedom. You can have segments that are diagonal, but we don't have such segments there, which makes it, and like the possibility of incorrect segments makes it difficult to check whether segments intersect or whatnot, right? So what I propose instead is to implement a segment as a pair of two constructors. Horizontal and vertical, right? Vertical. Maybe we're gonna call it hor and ver, and maybe this thing can be segment, like horizontal, vertical. So if it's a horizontal segment, so that means first value of it is gonna be y, and it's gonna have two axes, x1 and x2. The same goes with vertical, right? The same goes with vertical. It's gonna have essentially, so if this is a y, this thing is gonna be x, and this is a bunch of y's, right? So, and that simplifies checking this entire stuff dramatically, because intersection, if you have an intersection of two segments, right? Right, what is it going to be? I think it's going to be just a point, right? It's going to be some sort of a point here. So you only need to look for things that horizontal, vertical, or the other way around. Any other combinations are automatically false, right? So this is going to be maybe and automatically nothing. You see, if you represent segments like that, it makes it super easy to just check the intersection, if you know what I mean, right? So you can even do something like this, where you can do it like that, vertical, horizontal, where it is equal to the intersection of horizontal, vertical. So essentially you will only need to implement this one case, right? Only this one case, because the opposite case, the mirrored case, is just basically redirects back to this one. You see what I mean? I think it's actually pretty cool. Yeah. So, what if two horse touch tips? Then you get banned off of Twitch. That's what happens. MongoDB. So maybe I'm gonna replace intersections with something like intersect. Right, it's just a little bit shorter. And yeah, so this is essentially what we'll need to implement here. What we'll need to implement here. And the question is, when do these things intersect? So if it's a horizontal, this is y, and this is x1, x2. Right, this is x1, x2. And if it's a vertical, this is x, and this is y1, y2. So, okay, essentially you have a horizontal and vertical. So the x of the vertical have to be between the axis of the horizontal. So this x has to be between this axis, right? It has to be between this axis. We can put it like this, I suppose. So, x1, x, Have you done any half float for OpenGL? No, I haven't done anything for OpenGL. I don't even know how to do anything for OpenGL. Okay, so this segment is between the axes. But is it enough? I think another condition that we have to meet is that the y of the horizontal have to be between the y's of the vertical. So this is like the second condition. And y1 is greater than y and y greater than y2. And if that happens, we know the point of intersection. What's going to be the point of intersection? Believe it or not, I think the point of intersection is going to be xy. It's going to be just xy. Otherwise, nothing. You see how easy it is to implement the intersection between two segments, like just representing these things correctly. I don't even know that geometry that well, right? But if you just have like orthogonal segments, it's just like easy as that. It's amazing. It's actually fucking amazing how easy it is. Holy fuck. Yeah. You see? I think it's pretty cool. Does it even compile? I'm not sure. Let's actually see if it compiles, and it doesn't because I just put the at the wrong position. Intersect, it has to be hor and y. Oh shit, intersect is actually taken by data list. By data list. I poked. Why is it so fun? Thank you, Gil. I really appreciate you. So deriving. We can do hiding, but I mean, I don't want to do hiding. Because I might need something from data list, and yeah, whatever. Inter. Okay, so it does compile. It does in fact compile. It's pretty pog, not gonna lie. It's pretty pog. Okay, so now we need to be able to parse these kind of things, I guess. So maybe we can like have a type for the directions. All right, R, D, L, and U. Something like orthosections. That's a pretty cool name, but it's long. Direction. So direction is going to be. So what do we have? R int, L int, U int, and D int. So that's what we have here. And we're going to do deriving show. Right. Deriving show. So essentially it just represents like one of these values. And what I want to have, essentially, I want to have a function that accepts list of these directions as we get them from the input and gives me the list of the segments that I can then iterate through and check if they intersect or not. You see? See what I mean? So how are we going to call this thing? Sections of segs of wire, right? Because this is a single wire representation, right? It's a single wire representation. So we need to implement this thing somehow. We just need to implement it somehow. Segs. Very funny. Current coordinates too? Don't know. Stop. Reply, stop. You make me gigglish. I'm a little bit tired. So it's actually coming along very well if you come up with like the right types, right? So you need segs and dirs. But I also need a little bit of tea. Chat, who wants segs? I've got some segs of wire. All right. So essentially, I also want to have a function that takes a current position. I'm already tired, as you can see. Anabotho, you're still there. You're still watching the shit. Nice. Cool. Yeah. So, and also we need a direction. So we have the current position and we have the direction. And what we want to achieve here is segment. This is a 30 years old man. Yeah. Watching. Oh, you're just looking. Wait, are you working? With 31st December? Holy shit. I hope you're not working right now. To be fair, I'm technically working right now, but... is that really work? Imagine calling Twitch your work. So how are we gonna call this function that accepts the current position and... I was watching some videos with a friend. Oh, okay. I see. But also, so this is gonna give me a segment, right? Working to working, but also it needs to give me the next position so I can reuse it later. But what's funny is that I can recover the next position from the segment itself, right? I can recover it from the segment itself, but on the other hand, I can do something like this, right? So essentially it's going to be move to, right? So there's going to be a function that accepts the current position, takes the direction and moves that thing to a different direction, right? So that's what's going to happen. But then we'll need another function that constructs a segment, right? So something that takes these 2 points, right, and turns that thing into a segment. So and how it's going to turn it into a segment? So we have x1, y1, x2, y2, right? And for example, if x1 equal to x2, right, x's are equal, so that means it's vertical one, right? It's a vertical one, so that means this is going to be vert, and in the vertical case we just provide x1 and y1, y2. In a different case, there's going to be y1, y2, so this one is going to be horizontal, so y's are equal, so that means x, okay, so this one is going to be y1, but this one is going to be x1, x2. So, and otherwise, we should throw an error. So there's some sort of a problem here. So we have some sort of information that is not encodable in the type system, or I just cannot properly encode it myself. And it feels like it could be avoided. It does feel like it could be avoided, but that's what I think about it. Yeah. So what we can have here, invalid seg. So how are we gonna call this function? We're gonna call it make seg. Right, so it's gonna be make seg. So what do? We start at a particular position at 0, 0, iterating through the directions and generating new points. We're generating new points. And then we're going through the pairs of these points and generate segments. So that's essentially what we're gonna do. Okay, and how we're gonna move? So we have X and Y, and we have a direction. So what kind of directions do we have? So let's call it N. So we have right, left, up, and down. And this is essentially what we need to do here. We just need to move this point to a particular direction. Right, so yeah, let's quickly do that. Boom. Okay, when you want to move to the right, you want to move to the right, you just do plus x. Plus x. When you want to move to the left, you do minus n. Up, minus n, plus n. So that's what it is. So wait a second. Wait a second. Right, up. Does it really matter? Does it really matter? Because it's a taxi cab distance, right? So it's a taxi cab distance. It doesn't really matter how we represent things. Yeah, it doesn't really matter. Happy New Year to you too, PRKGR. All right, so this is basically how we do all of that. So we have a make segment out of 2 points, and you can move the point here. Right, so the next thing we need to do, we need to start iterating through all of that. To be fair, it would be better to swap these things around. So once you provide the direction, it's more of a just having a function that moves from one position to another. Something like this. So how are we gonna approach all of this? So you have a bunch of directions. You let's call them dirs. I'm gonna do map move to, and I'm going through all of the dirs, right? So that gives me a list of these functions, that I have to. This one is interesting. Okay, so I can try to fold. I think we need something like scannel. Do you guys know what is a scannel? Yeah, we need something like scannel. So where can I check for its scannel? Okay, so essentially it accepts an accumulator just like Foldle, right? Just like folder. And it's pretty much like Foldle, but instead of returning a single B, it returns a list of Bs, right? So it returns you like the trace of the state. So, and maybe this is exactly what we can do here. We can do scannel. We're going through the directories, and the initial state is going to be 0, 0. So you start at 0, 0, which is a center. And what's funny is that you can swap it back, and this is exactly going to be your function. That's actually pretty cool. So, yep, like this. And yeah, cool. That gives you a bunch of points. We can actually try to see how it goes. Oh no, I used my reflexes again. Imagine a world where we could make 6. Okay. I need to reload this thing. Okay, it still compiles. That's actually pretty cool. So I need a bunch of directions. So if I try to segs of wires, it will give me just 0. Okay, so what if I try to go up 1? And it went up because negative is up. It actually depends, right? So maybe to keep things symmetrical, I'm gonna actually keep it like this, right? Right there, up is there, down is there, because it doesn't really matter that much, right? So you can do something like this. It's gonna be, I can do 5, it gives me 5, then I can do 10, and then I can move to the right like 1. Right, it gives me the next element, and so on and so forth. So basically, I can turn the list of these actions, steps, right, into the list of corresponding points. You see what I mean? List of the corresponding points. But this is not what I want to have. I want to have a list of segments, right? So I'm gonna put this into something like this. So here's the point. Next thing I need to do, I need to connect them together. So essentially I need to zip these things with PS with the tail of PS, basically offsetting them and making the first point and the next point corresponding points. And we're gonna just use function makeseg as the function that connects them together, and it will produce the list of segments, hopefully. So if I try to compile that, and that gives me the list of segments. So the first one was vertical, right, because we were moving up 10, and the next one is going to be horizontal. There we go. So that's kind of cool. Goes up and then down immediately and counts as an intersection. Okay, so in the description they say the wire does not intersect with itself. All right, so let me continue. Hello, Daft Maple, welcome to the stream. All right, so we have that, which is cool. But we also need a way to parse this segment, right? We need a way to parse a single, not segment, but direction, right? So parse dir is gonna accept the representation of the direction and return you the direction. Right, there you go. I need to make a cup of tea, chat. I need to make a cup of tea. It's actually a very interesting problem, and I wish I could get rid of this otherwise case. I wish I could get rid of otherwise case. You seem tired? Well, yeah, I need tea. But it feels like it's kind of difficult to get rid of it. Sort of, kind of. Yeah, it's kind of difficult to get rid of it. Oh, by the way, do we still have the current year in still? 2020. Oh, it's still 2021. 2021. So, by the way, still command automatically updates the year. So I coded the bot long time ago, so it does in fact update the year. It does in fact update it. Okay. Does anyone have any questions, by the way, while I'm making a cup of tea? Maybe about the problem or something like that? So yeah, the only thing we'll need to do here is just to parse this stuff. Should be pretty straightforward. So yeah, I'm drinking Earl Grey. What if the two vertical segments intersect? What if they don't? So we still command will break v1, probably. I don't know. It actually uses UTF time. I'm drinking Earl Grey. All right. So I'm gonna go to the kitchen and turn on the kettle. Don't go anywhere, or I will come to your house and drink all of your tea. So yeah, it's gonna be super quick. So just turn on the kettle and that's it. Okay, how's it going? How's it going, everyone? I came. So, parse dir. So if I remember correctly, you can have a function uncons, tuncons, which takes the text and basically destructurize it as it would a string. But text is not a string, that's why you need this kind of functions. Right, so here's the input, right, and we do tuncons input. Case of, and we have just, yeah, and we're looking for specific things here. So we're looking for something like u, and then x, right, so we can call it s, right. So in this particular case, what we need to return here is u, t unpack s, and straight up read it. There we go. And we need 4 of them, so it's going to be, actually let's start with r, l, u, and d. So if we have a situation that is not taken into account, we're going to do something like error, maybe even print f, saying something like s is not a correct direction. Put the input here. There we go. So now we're capable of parsing input. We can even test that a little bit, and we don't have a printf because I never actually inputted it. So now if I try to parse dir u69, and there you go, we have a u69. What's up, Old9? Good morning. How are we doing? We're just parsing some stuff. Yeah, so now we can just take a list of these things and parse them and turn them into wires, and then turn them into segs. Yes, we can turn them into segs. So let's see if we can easily do that. So this is what we're gonna have. Yep. So split on this thing. Then we're gonna do map parse dir, boom, and then we do segs of wire. Yeah, segs of wire. Boom. So here are all of the segments. So here are all of the segments that we've got, and that's pretty cool. So yeah. Why did you shave? Hope not medical reasons. No, not medical reasons. Mental reasons. Joking. Everything's okay. So, okay. Looks cool. And now we need to be able to actually read the input, right? So we need to read the input. So let's introduce something like read input, and read input is essentially going to be returning a pair of list of segments, right? So this is what we're going to have here, pair of list of segments. So what we're going to do, we also need to accept the input file path, like this, file path. So if I try to do t-read file path, that should give me only 2 lines, and I can try to do something like unlines. No, just lines. And just assign it to first and second. There we go. So we have 2 of these things. So then, so we have a parse direction. Maybe we need to introduce something like parse wire, which will take a text and give you a list of segs, right? List of segs. So this is going to be the input. We do a split the input on a comma, right? Then we map it with parse dir, and then we apply segs of wire. So what's interesting is that we can use a point-free notation for this specific case. So we can do something like this. There we go. So parse wire, and that's pretty cool. No Baldy machine today. Yeah, I guess I'm gonna actually do virtual machine on Mondays, Tuesdays, and Wednesdays. On Thursday we're gonna do Advent of Code, and on Friday we're gonna do a random topic. So that's my plan for the near future, at least. Yeah. So, and here what we're returning, return, so it's gonna be parse wire first and parse wire second. So the question is, what if it has more than 2 lines? I think I want to ignore the rest of the lines, so that's why I'm going to do the following thing. Lift your skinny fists like antenna to heaven. Are you telling that to me? Do I have... I don't know, is that an insult or something? I don't understand. Okay, so this is how we read the input. It's a music reference. Oh, I see. I'm sorry. I'm very uneducated. Okay, so I can read the input and everything looks okay. Everything looks okay. Yeah. So let's try to... okay, so there's no... it cannot do a second. Ah, it has to be T lines. I see, I see. Okay, it works. So now we have this input. And now we should be able to read the input from that specific file. And there you go. So it gave us the input of different segments and shit like that. And what we need to do now, we just need to take these two lists of segments and brute force them. So basically we need to iterate through all of the pairs of these things and find the ones that intersect. Right, find the ones that intersect, and then find the closest point of intersection. We already have a function that finds the point of intersection, so the only thing we'll need to do is find the closest one. Pretty straightforward, I would say. Yeah. So first thing we can try to do, we can try to generate the list of points of intersection, I suppose. Yeah. But before we're gonna do that, I need to brew my tea. So my kettle is already done, so I'm gonna go to the kitchen. Don't go anywhere, or yeah, I'm gonna rewrite all of your applications in Haskell, and they're gonna be slow. I know how to write slow applications, trust me. Okay. All right. But I already rewrote them in Rust. It's too late. Okay, so maybe I'm gonna introduce something like part 1, where I'm gonna accept the file. Maybe I'm gonna literally accept just a sequence, like 2 segments here, segment 1 and segment 2, a list of segments, of course. And what do I need to return? I think I need to return... What is the Manhattan distance? Okay, so I need to return the Manhattan distance. It has to be like an integer. Do you know Scala? Do you have any thoughts about it? I don't know. I worked on 2 commercial projects in Scala. I don't have any particular thoughts about it. It's just yet another language for me. Yet another language. First, second. Okay, so here's that. So maybe I'm gonna call them X's and Y's, so it's easier to iterate pair by pair or whatnot. So X of X's and Y of Y's. Okay, and then since X and Y's are segments, right? X and Y's are segments. I can just do and like I can just intersect them, right? So if I try to do something like inter X and Y, that will give me a list of maybes. That will give me a list of maybes. So, and now the next thing I'll have to do, I'll have to filter out all of the nothings, right? All of the nothings. The easiest way to do that, I think, would be to use map maybe. I think it's map maybe. Yeah, you'll have to import first data maybe to have an access to this thing. Map maybe. Yeah, yeah. So essentially, it takes yeah, it takes a function returns maybe, and applies it and filters out automatically everything that is nothing. So what I'm thinking here, maybe we can do map maybe ID, and I have a feeling that map maybe ID like could be like a single function. So let me take a look at the Google. Well, unlike ETA, Scala is used in production at least. So Scala is like a literal production-ready language. I'm not sure if anyone uses ETA in production, like as serious as Scala. Free Metro Redux on GOG. I don't even have an account on GOG. By the way, does it work on Linux, Belgian? Does it work on Linux? If it works on Linux, I could probably register there. Can you help me understand what static variables are in C? Sure. These are the variables that are not visible outside of the translation unit. It might with wine. Okay. So what I want you to do, I want you to take a list of maybes and just get list of A's. Is that a thing I can do? Or do I have to use map maybe? Maybe I could just use hlint to tell me how to do that. Cat maybes. A big hairy woman subscribed with Twitch Prime. Thank you so much, a big hairy woman, for Twitch subscription. Your first subscription, by the way, and welcome to our epic maybe club. That's right. It's a maybe club. Maybe it's not a club, I don't know. Yeah, so cat maybes, but that's actually cool. Takes a list of maybes and returns the list of all just values. Oh shit, that's actually perfect. I can just do cat maybe. Long time worker, happy to join the epic club. Yeah. You are welcome. You're welcome. So that gives me all of these intersection thingies. And we need to calculate the Manhattan distance. So how we're gonna calculate it? You know what? I'm gonna just return like a list of these intersections because I want to take a look at them. I just want to take a look at them. Cat maybes, we need to import data maybe. There we go. Cat maybe didn't work. Excuse me. It's a part of the base. Are you telling me that I'm using? It's cat maybes. It's several of them. Okay. I'm sorry, Mr. Compiler. There we go. So now I can try to do part one. So I'm gonna read the input from the input.txt. Here's the input, and then I'm gonna do a part one on that input. Chat, why don't you ask me why I'm still on a part one? It's been 3 hours and I'm still on a part one. Yes, programming in Haskell is hard. It's so hard, I'm still on a part one. Why are you still part one? Because Haskell is hard and I'm bad. Because I'm bad. Well, the reason is it's a day 3. We actually started from 0 today. We solved already day 1, day 2, and we're solving day 3. So yeah, 1 day per hour, pretty much. It's not a title. I mean, I updated the title. What are you talking about? Excuse me, I updated the title. Yes, the title is updated. Refresh your page. So, are you guys ready for a little bit of a, GSMR? It's difficult for me to build app intuition as to use the don't know what to call it, monoid, semigroup, monad stuff. Well, then don't use it. Actually, you don't need to know what these things are to program in Haskell. Just don't use them. Seriously. Yeah. like for the first, I think 5 years, I programmed in Haskell without knowing any of this category theory shit, and I actually did pretty complex stuff on it. You don't really need anything. Yesterday it was the virtual machine, and today what? Well, we have a special command. So if you're interested what we're doing today, you can do exclamation mark, and guess what? Today! And bot will tell you what we're doing today. Holy shit! Isn't that amazing? That's the future, that's the technology. Holy shit. Hamikovi.
Still on part 1.
Yes, I'm on part 1 just to bait some donations. I'm joking. Thank you so much for $5. Thank you for supporting the channel. All right. Can you have objects in C? Depends on the definition of an object. Having some fundamentals of mathematics can help you understand. Yes, I do agree. Like, you need to know arithmetics. Why to day 1? What? Wait a second. Don't tell me it's on day 1. Oh, for focus sake, mate. Update CMD project. Thank you so much for telling me that it's still on day 1. It's day 3. Yeah. Static variables declare inside functions in C retain their values between function calls. Yes, it is true. But if they're defined outside, they just become invisible outside of the translation unit. Essentially. And by default, the symbols are usually visible outside of the translation unit, I think. I'm not that big of a C guy. And here are all of the points of intersection for our input, believe it or not. There's not that many of them. Holy shit, why there's so few of them? Yeah, there's literally 16 points of intersection. That's kind of interesting. So for those who doesn't know, what we're doing here, we're trying to find the points of intersections of 2 wires on the panel. So the wires are actually pretty long and, you know, zigzaggy and stuff like that. And yeah, apparently for our input, there's only 16 points of intersection. And what we need to do here, we need to find the closest to the 0, 0, right? That's what we're trying to do. So I think before returning them, I'm gonna try to sort this thing by their length, right? By their length. And their length is actually pretty straightforward. So what we need here is f that accepts integer, right? Integer, and returns the distance. We can call it just a distance, dist, right? So it's gonna be x and y, and the distance is equal to the absolute value of x plus absolute value of I. And do we have ABS? I don't think we have AB. Well, I mean, it's supposed to be T. Yeah, there we go. That's what I'm talking about. Alrighty. And so that should be pretty straightforward. So when I do sort by, I need some ordering. So that means I can sort compare on distance by comparing them by their distances. And to have something like on, I need to import data function, right? So after that, if I try to do this thing one more time, okay, there is no int here. What the fuck? Excuse me. Because this thing accepts 2 of these things. Okay. Am I an idiot? I think I'm an idiot. What am I doing with my life? Sounds... Yeah, it's actually... I think it was kind of the point of the function on. It was kind of the point. Let me do data function. Yeah. So it accepts the function for the comparison. Yeah, it's kind of interesting. So here's the value. It applies this function to this value. So here's 2 arguments. It applies this function to the first argument and the second argument, and then reduces the 2 b's you got by applying this function with this function. And this is the way you can do compare on some particular function. You can compare on length, you can compare on distance, and so on and so forth. This is actually pretty cool. Alright, so if I try to do that, it should be okay. And now, if I take a look at the intersections, I think this one is the closest one, right? This one is the closest one. Oral exam. What's the Manhattan distance from the center to the closest intersection? Well, we can literally, to be fair, we can just literally map this entire thing, right? We can map with distance, then sort it, and then take the head of it. Alright, so that's a little bit easier, and then we can just return int, right? Then just return it and see. So maybe we're gonna also try to do that on a sample. Here's a few examples. Okay, so we can try to do that and just test it on the samples. Alright. So sample 01txt, sample 01txt, so this is gonna be our first sample. And I'm gonna try to apply the solution on the sample 01txt, and it's 0. Fuck. Very interesting. Okay, so how did that fucking happen? You know what? I wanna have a function that accepts two wires of the segments and just returns me all of its intersections. So I'm not sure how to call this function, but essentially what it's going to do is going to do that, right? And then we can have f, x's, y's, right, like this. It could be also something like this, right? It could be also something like this. They intersect at origin, which isn't counted. But why don't I have it here? Oh, maybe I do have it here. Wait a second, that's really strange. I don't have a 0 here. Anyways, anyways, intersections. Well, I have function inter already. I can call it inters. I just don't want to type too much, so that's the problem here. I'm sorry. Just don't like to type too much. Okay, so there's x's, y's, and yeah, we'll have to have x's and y's. Okay. So read the input, and this is going to be sample 01txt. Here's the input, and that's cool. And it's going to be inters. This is very interesting. They do start at 0, 0. So they do intersect at 0, 0, which doesn't count, right? I do understand that. It doesn't count. But why it is not a thing for the input then? So that means I implemented something incorrectly for the input. Because if I try to do this input, right, they don't have 0, 0. At least I don't see it. At least I don't see it. So when I read the input, I parse a wire, and when I parse the wire, so then we use segs of wire, and we start from 0, 0, right? We do start from 0, 0, and that's exactly what we have here. So I don't quite understand. Like, they should intersect at 0, 0, but they don't. And by the way, in inters, if I map them with distance, right? If I map them with distance and then I try to sort all of that, yeah, they don't start with 0, so something is definitely wrong. Maybe my input wrong, but even if the input wrong, by the way, even if the input wrong, they should still intersect at 0. So that means I'm just doing something wrong. So they actually go... Oh, I see. So we only considering them intersecting if they're opposite orientation. But these two things are intersecting as well. And they have the same orientation. I think I did a fucky wacky chat. But would we have a situation? Today I found out you can use pendulum type thingy to carry out mug, and it's way harder to spill it. I already switched the context. This is not good. Huh. That's pretty cool. Alright. So what I'm thinking, maybe we need to take into account some of the situations when you have both horizontal and both vertical of some sort. I think we need to take them into account somehow. So let's actually try to do that. We're gonna have let's do hor. 1 is gonna be something like this. 2. First of all, horizontal has y1 and another one outline. Come on, y2. It's a horizontal. All right. So right. So y1 equal y2. Right. y1 equal y2. And that means they can potentially intersect. If their ends touch each other. Will their ends ever touch each other? That's a good question. But what's interesting is that if they overlap, it's gonna be a complete fucking disaster, right? So that's kind of the problem. So this is a Oh, and there is another interesting thing. I'm kind of assuming that x1 is less than x2 and y1 is less than y2. So that's another like a wrong assumption that I'm making here, which is kind of bad, and I shouldn't probably make it. So I would like to have a function that accepts a pair of integers, right? And basically, if x1, x2, if x1 greater than x2, x2, x1, otherwise x1, x2. You see? So that's what I want to have. And then I want to do something like this. When we are making a segment, right, we're making sure that it's in a correct order. So, but I'm not sure how to call such function. We can even put it at where, somewhere under where. So how should we call it? So it's f fix orientation. Maybe. Let's call it maybe fix. Sounds good. So I don't really want to call it too long. Okay. So so this is another thing we're doing here. It does in fact compile. Cool. So now we can make sure that when we intersect the segments, we know that these ends like are correct. Hopefully. All right, so if we have that, we bring them back to this particular situation and everything should be okay. So horizontal one at y1 is going to be lower x1, high x1, like this. So in this one is going to be another horizontal where you have 2 for these things. Right, 2 for these things. So what we're looking for? We're looking for the situations when this, like the high end is equal to lower ends of that one, like hx1 equal lx2. So this is one case we're looking for, and similarly to h2 right? So you see what I mean? Yeah. Oh, and their y's has to be equal. Yeah, so this is quite important. So we're only looking for the situation when their y's are equal. Y equal y2, only then, and this is like sort of like a sub-conditions here. Since there are sub-conditions, into the corner at the orthogonal direction, which is covered in the previous cases. You said too many words, I cannot parse them, I'm sorry. So essentially what I'm trying to do here is I want you to throw an error when one of these cases happens. That's what I want you to do, essentially. But maybe I'm not gonna do that. So maybe it would be enough for me to just ignore the zeros position. Yeah, I think we can do something like this. It's gonna be filter greater than 0. So I think I'm just wasting my time on that one. All right. So where is the sample? So we have a sample 1. So here is the sample 159. Okay. So read the input sample 01, and it's gonna be part 1. 159. Cool. Sample 2. Sample 2. So here's the second sample. And it's 135. Would you look at that? So it is correct. So like I wasn't sure if it's safe for me to just do this and filter out the 0. And I think it's safe. I think it's safe enough. Let's actually run it on the actual input. So let's grab the input. Right, let's grab the input one more time just to make sure that I'm working on the right one. And let's take a look at it. It's 1064, not even 69, unfortunately, but okay. There we go. First try. The 5th first try of the stream. By the way, all of the attempts so far were first try. And there were 5 of them. Alrighty. So let's go to the part 2. Interesting part. It turns out that this circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wires' steps is the lowest. This is very interesting, actually. Holy fuck. If a wire visits a position on the grid multiple times, use these steps. If a wire position use this steps value from the first time it visits that position when calculating the total value of a specific intersection. The number of steps a wire takes is the total number of grid squares. Grid squares the wires has entered to get to that location. 10 for small Google break. God damn it. Ah. Okay. So, okay. The number of steps of wire takes is the total number of grid squares wire has entered to get to that location, including the intersection being considered. Again, consider the example from above. In the above example, the intersection closest to the central point is reached after 20 steps by the first wire and 20 steps by the second wire, for a total 20 plus 20, 40 steps. However, the top right intersection is better. Top right, because it's closer. I see. I'm gonna sneeze, by the way. No, I'm not gonna do that. Okay, so here's the example. So this is the part 1. What is the fewest combined steps of the wire must take to reach an intersection? Debated. Debated by a sneeze. That's very interesting. So, that's pretty cool, I would say. Because now an intersection, right, an intersection should also give you information about the amount of steps. Right, so we do an intersection between two segments, right? And that gives us the amount of steps we've taken, right? That gives us the amount of steps we've taken. But to calculate that kind of information, so the segments themselves have to store that information somewhere, right? Maybe we can associate that information with one of these constructors here, right? So basically, we can store the amount of steps it took to reach the beginning of this segment, right? And that enables us with calculating the amount of steps total for that specific intersection, right? You see what I mean? Should be pretty straightforward to implement as well, but I think the problem is that we don't have information about where the segment starts. Where the segment starts, like, does it start from that end or from that end? Well, maybe we had some sort of information, but we lost it with fixed orientation. So I think we kind of lose some information here with fixed orientation or something like that. I think that's exactly what's happening here. So yeah, we'll probably need to fix up everything here before we continue. I wonder if I went with a grid approach, it would be easier for me. I don't think it would be easier for me because, like, there's several layers. Okay, let's think about the grid solution, right? So the problem is that we don't know the size of the grid, but we can sort of optimize it or something. Essentially, if I went with the grid solution, I would probably need two grids, right? The grid for the first wire and the grid for the second wire, right? And then I can basically store the amount of steps it took on each individual grid and just go through all of the intersections and just find the one that take the lowest amount of step. So I guess yes. The easiest approach here would be to actually go with the board solution. Yeah, that's the easiest solution here. God damn it. So yeah, we need to restructure the whole solution now, I think. Because the approach I've taken is not particularly optimal because it makes it kind of difficult to implement the solution. So we need to change the data structure. Bro, Pahia, I'm sorry, but I don't speak Russian. Well, I mean, I do understand Russian, but I would really recommend you to speak English here because it's a English-speaking channel, and majority of people just don't understand what you're talking about. I guess you need to have the whole steps stored in the take while first step. Yeah, so that's why I said that this approach is not that useful. So we need a different approach based on the board. We need a different approach based on the board. Okay. So, but to create a board, we need to know the borders of the board, right? So what's the minimum value, what's the maximum value, and so on and so forth. And I think we can try to calculate it, right? We can try to calculate it. So we do have a segments, and every time we create a segments, right? Yeah, we need something like this. So we have a parser direction that gives us a direction. Then we have a segs of wire. Within the segs of wire, oh yeah, I see. Scanner move to direction. All right, so we're gonna read the file. We're gonna read the file input.txt, and we're gonna try to parse the direction. So essentially, we split on the comma, right? We split on the comma. Map parse dir. And there you go, here are all of the directions. Here are all of the directions, and then I can do something like scannel. Oh shit. Something wrong went. Oh yeah, it's a... God damn it. I just need to find the boundaries of them. And maybe boundaries are not that important. Maybe they're not that important. Because what essentially you can do is, if it crashes, you can always expand the boundaries, right? You can always expand the boundaries. So it shouldn't be that big of a problem. Okay, so let's define a board. Let's define a board. A board is going to be an array that uses a pair of integers as an index and integer as a value. Right, so this is going to be our board. And I want to have a function. Are we down? We're down. We're fucking down. Refresh the page, Chad. Refresh the page. Refresh the page. I can see the problem. Yes, yes, yes. We're back. To back. We're back to back. Okay. I'm really sorry. Something with my internet. Maybe it's just because it's a new year. Everyone is using internet or something. But yeah. Okay, I defined the board, which is the two-dimensional array, and I need to create a board. So what we're gonna accept here, we're gonna accept the dimensions of the array, of the board, and we're gonna just create that board here. So, and how we're gonna create that board? The first one is gonna be definitely width, right? It's gonna be x, and the second one is gonna be height. So now I need to create. Well, to be fair, I can just iterate this stuff. So we're going to do x 0 up until width -1, and then y up until... The thing is, we also can go negative. So that's the problem. We also can go negative, which means that we need actually the ranges of x's and ranges of y's. So it's going to be x1, x2, and this one is going to be y1, y2, right? So that's essentially what I'm trying to achieve here. So this is x1 and this is x2, y1, y2, right? And so here are all the axes, and these are going to be the indices. So the index is going to be xy, and we're initializing all of that with 0, and we're constructing an array out of that. But that's not enough, because I also need to define the range, and the range has to be x1, y1, x2, y2. So that's essentially what I need to do here. So this is how I can create a board in Haskell. All right, so if I reload, it actually works. We can try to create a board from -5 to 5, and for x and for y it's going to be from -5 to 5. And there you go, we managed to create a board. And I don't quite remember. Yeah, I think it's all right. I think it's all right. Okay, so here's the board. That's pretty cool. Another thing is now I need to implement a function that steps in a particular direction, right? You step in direction, so it should accept the direction, right? It should accept the direction and accept the board, and it will return you a new board, right? A new board where, starting from a particular point, from a particular direction, it will leave the trace of the steps, right? It will leave the trace of the steps. Maybe, to be fair, it would be better to be able to dump the board, so it's a little bit easier to actually inspect what the hell is going on, right? So we can have a board, and it will print that board on the standard output. All right, so that's what we're looking for, at least. Sure how easy it would be to implement, but we can try. Yeah, so let's actually turn it into a string. All right, so this is the board. And how do I get lower and upper indices of the array? How do I do that? That's a good question. So let me find the array interface. Data array. Yep. Okay, there we go. Low. I think it's something like indices. Does anyone know how to get the indices of the array? Oh, there we go. This is how we do that. Bounds. That's what I wanted. I wanted bounds. Yeah. Hello, Pika. Welcome to the stream. Bounds of the board. So what we're looking here is actually x1, y1. So this is the first thing we're looking for. And x2, y2. And there we go. So we have the boundaries, which is quite convenient. So the next thing we can do, we need to start iterating by rows. All right, so we're doing it like this. Iterating by rows. Y, y1, y2. Should be like this. And then within this entire thing, this entire thing, we will get x, starting x1, x2. Okay, and within this entire thing, we'll be able to query the board like this. It's going to be x, y, and that should give us. Did you donate your hair to cancer patients? No, I didn't donate it to anyone.
You donate the hair to cancer patients.
No, I'm sorry, I didn't actually throw it away. It wasn't that good of a hair anyway. Thank you so much for 15 months of tier 1 subscription. Thank you. And welcome to our epic Haskell club. All right, so let me see. So this is the board, we can query that, but this is just a number, and I want to turn this number into a string, and I would like to join the each individual line with, you know, spaces or something. Like I think it could be unwords, right? So we can try to unwords this entire thing, and then unlines, and it doesn't want to cooperate for some reason. I don't understand why. Like I did list comprehension before in Haskell. Haskell list comprehension. Do I do something incorrectly with this comprehension? Why is this not correct in Haskell? Why is this not a correct Haskell? Is my internet okay? Okay, it seems to be okay. Yeah, well... Wait. Ah, okay. Where is it? I think I did it correctly. I'm pretty sure I did it correctly. I don't know. So if I try to do something like this, right? And then within that thing, this is a new thing. 32. It says at 32. Wait. I'm confused. Okay, let me try to reload everything. It's 19. Ah, oh my god, I'm an idiot. Holy shit. Did I get... Okay, this is okay. So, yeah. So now we should be able to dump this entire thing somehow. Let's try to compile that, and here is the board, right? And then I can try to dump the board and then print it like this. Oh, there we go. This is exactly what I was hoping for. So I can create a board, and then I can actually dump the board. So this is not really dumping the board, it's more of a showing the board. So this is show the board, and we can use that while we are, you know, debugging everything. So now I want to do the following thing: step the board. So you accept the board, and you produce a new board. So this function modifies the state of the board. That's quite important. So we're starting moving from a particular point on the board, and we're also accepting a particular direction in which you want to move, right? So a particular direction in which you want to move. And that lets you go somewhere. So here we go. It's XY, and the direction could be something like right, and the amount of steps you need to take, and the board that you need to modify. Right. So for the right, when you move into the right, you actually need to generate values. 1, 2, 3, 4. Yeah, starting from 1 up until n, right? Starting from 1 up until n, then you map all of that and produce. So you move to the right, so x plus 1, so x plus I. So here are all of the indices through which you have to iterate, right? Here are all of the indices through which you need to iterate. But on top of that, you also need to set a value there somewhere, right? You need to set a value there somewhere. So what's going to be the value? The value is going to be the value of the xy coordinate plus I, right? So, and what's that value? We can get it like this: 1xy, and then we can treat this as an index. And the value is going to be plus I. There we go. So that gives us the list of the indices that we need to modify, and we can straight up put them into the board. So that is it. So that should be the solution that makes a step. So we can create a board. So here is the board. Well, it's actually show the board. I renamed this function. Cool. So now, what I want to do, I want to step the board, as already mentioned. Step board, I'm starting at 0, 0, and I'm moving to the right once. You see? 0, 1. If I move to the right twice, it's 0, 1, 2. And I can move how much I want. I can move 5. There we go. So this is basically the function I have. It's pretty convenient, right? So you start at a particular point and you can move there, and then we can sequence several of these actions, right? If I actually try to step over the board, what's gonna happen? It's gonna have like an array index exception. What's up, Potato passing by? Welcome to the stream. You're not gonna have a brain break here because we're programming in Haskell. I'm sorry about that. But yeah, so here's what we have. A step board. We have a step board. So which is quite convenient. So if we take a look at some of the samples, it's like 100 by 100 and so on and so forth. We need to implement the rest of the things. We need to implement the rest of the steps. To be fair, I could copy paste some of this stuff, but I think it would be better to do something like direction here. Dear. And then we can have a case direction off, and here we have what it was a right n, right? So this was a right n. So we need like 4 of these. This is going to be left, which is essentially minus I. Up is going to be plus y, up is going to be plus y, and down is going to be essentially minus I. There we go. So we now have all of the directions here. So yeah, let's do 5. So here's the 5. I can go now to the left. So here's the... That is really strange. Okay. Okay, that makes sense. And then I can go to up. Well, it went up. Okay, so that makes sense because it displays it like that. It doesn't really matter, to be fair, right? So we can switch them around. The the distance is not going to change. The distance is not going to change. So this is going to be up, and this is going to be down. So we need now a way to chain these things together, right? To chain the boards, so to speak. To chain the boards. How are we going to chain the boards? So step boards, wire board. So and essentially, if you're wiring a board, yeah, we can do something like that. So when we have like a sequence of these things, so I think the easiest thing to do here would be to ignore everything if you don't have any directions, right? If you do have a direction, you need to keep track of that direction though. That's the problem here. You need to keep track of that direction. I mean of the position. So that's the 2 things you have to keep track of, unfortunately. All right. That is very interesting. You have to keep track of that position. Ha. All right. We can probably restructure step board to maybe, accept these 2 things like that, right? And return like board with the new position. You know what I mean? Board with the new position. Is it gonna be better? Is it gonna be better? It's probably gonna be better. It's gonna be probably easy to maintain. Yeah, so let's restructure it like that. So let's remove this wire, and so this is not going to be that anymore. So, and then we'll have to do it like that. So maybe I'm going to also introduce a cell. Right, so let's introduce a cell. So it's easier for us to reason about it. is gonna be like that. So this is a cell. This is a cell. Cool. So and that's exactly what we're returning here. So in here we can return like a new board. So this could be a board prime, meaning that it's the next board. So we can put it here. And of course it doesn't want to auto format it, right? Because it's a Haskell being Haskell. If it's not compilable Haskell, it won't allow it to auto format. Oh, it says it's already formatted. Okay, that's cool. Yeah. So here is the cell. So here's the direction, and that's what we do here. And what we need to return here, essentially. Oh shit! It does depend on the direction. It does depend on the direction. This is actually kind of bad. Okay. So yeah. Cool. So we still need to return this step, this thing, x, y, like this, and cool. So in case of that, it's going to be x plus n. In case of that, it's going to be x minus n, minus n, plus n. Cool. So that's what we have here. Is it going to compile? It does in fact compile. Cool. So now, if we try to wire the board, we're starting with a particular thing here. So So when we probably need to fold. Yeah. So now we need to just start folding, I suppose. Yeah, we just need to start folding. So this is the original point, the original cell, I would even say, the directions and the board. So, and we're starting to fold everything here. So we're starting to fold. We're gonna fold it with a step board. And here is an interesting part, because accumulator for the left is expected to be to the right. So then that means I'll need to move it to the right. Right, so that means we'll have to do it like this. Right, we'll have to do it like this. One more time. Alright, so we need to do it like this. Then step board, then cell, board, dirs. That should be it. I think that should wire a board. So you can have now several directions, and you can just wire the whole board. Hopefully we'll see. We don't have file, yeah, because what? Cell board with array cell int board. Oh yeah. So the final result has to be a board. So we have to take the second element of this thing, and there we go. It works. Essentially, why the fuck I was bothering with all of this shit? Okay, so we make a board, and instead of stepping a board, right, we're wiring the board. Right, wire board. We're starting at 0, 0, and we have a list of these things. So if you don't have any steps, it looks like this. Then we can go to the right 2 steps, and then we can try to go up 3 steps. So you see, right, up, right, up. Then we can go left, left 4 steps. So now we can go like that. So this is where we're going for. You see what I mean? You see what I mean, chat? Isn't it cool? So, and we can even dump this thing and see how it looks like and shit like that. So yeah, now we have like this sequence of step and stuff like that. And yesu, kawaii desu. And it took not that much code, to be fair. If you think about it, I don't know if it would be less code in C, to be fair. If you think about it, that's the whole code that is responsible for doing this squiggly thing. Would it be less code in C? think it will be like pretty much the same amount of code. I can probably even like squash it a little bit. But yeah. Now, what we can do here is we can parse the whole input. So if we don't even need to organize the segments or anything like that. So I'm gonna do parse input 2, and it's gonna accept the file path. I'm gonna call it part 2, right? Part 2. So it's gonna be file path. Hey, good luck with. Thank you so much for wishing me good luck with something. Okay, so we're gonna have 2 boards here. So yeah, so this is gonna be a file path, and we're reading 2 lines here. So this is gonna be first, then we're gonna have second, read file. Parse wire. Right, so we have a parse wire which accepts segments and stuff like that. Looks cool to me. So file path, and for this thing we need to split. We also have to split everything by lines. Splitting everything by commas. And mapping all of them. We're mapping all of them with parse directions, so we get the list of the directions, and then we wire a board starting from 0, 0. Here's the list of directions, right? This is the list of directions, and we need to make a board. So what's going to be the board? So we need to provide 2 cells here. We're going to start with minus 100, 100, minus 100, 100. So it could be something like a constant here, n. So let's put it like 100 here, and just reuse this constant everywhere, like this. So and this is going to be the first board, essentially, board 1. So we can make it a let of some sort. And we're going to have the second situation here, but for the board 2, we're going to have board 2. And what we need to return here, we just need to return board 1 and board 2. There we go. So it's not really write a board, it's a wire board. You can group RLLs into 2 groups together. I don't know what you're talking about. I think it's overkill. Okay, no grouping is required so far. Okay, looks cool. Is it gonna compile? It is not compile. Why? Because it has something to do with text. Okay. Parse dir accepts the text. Cool. Couldn't match. T lines. There we go. Cool. It does compile. Cool. So here's the next thing I want to do. I want to do part 1 on the input and see if it crashes because of the index. Okay, no instance for... Okay, you cannot... For data is string. It's a part 2. There we go. Array index is too small. What about 1000 by 1000? Too small. What about 2000? Error in array index. 5000? Oh shit, I'm sorry. I didn't reload. I didn't recompile. I'm sorry. I didn't recompile. So what about 1000? Okay, that's cool. Oh shit, it takes so much time. And error in array index, I see. What about 2? Holy shit, it's slow. These arrays are so slow. I'm not sure if it's a feasible solution, chat. These arrays are extremely fucking slow. These arrays are extremely fucking slow, so maybe we shouldn't use arrays then. That's a sadge. That's a straight up sadge. And on top of that, what if they intersect with each other? It's not gonna help with our step situation, I think. So if they intersect with each other, what's gonna be the step? Oh shit, it's too... it's too much work. Yeah. I see. Okay, chat, let's make a cup of tea. Does anyone have any questions? Does anyone have any questions while making a cup of tea? Yeah. You can ask me any question. So, does anyone have any questions so far? So I'm just kind of thinking that maybe I should go back to my idea of having segments. Maybe that's what I still need to do, because that will probably require less effort or something. Yeah, back to having segs. I think we're gonna go back to having segs. So I guess segs is the way to go. Segs is the way to go. It's also getting a little bit hot in here, so probably have to change to a t-shirt or something. What's up, Chan Per J? Welcome to the stream. But again, how can we do that with segs? Right, so with segs, we just need to keep track of the steps along with the segments. That's what we need to do, right? Along with the segments. So the segment can be just a horizontal or vertical thing. Just a horizontal or vertical thing. And just the horizontal or vertical thing could be like actually any direction, right? So it could be any direction, like from left to right or from right to left. So we need to know where it starts from. We need to know, so we need additional information here. Additional information. So the additional information that comes with the segment is, first of all, what's the amount of steps at the beginning of this segment, and where, steps. And where is the beginning of the segment, first of all? Like, where is that beginning of the segment? So, and after that... So, maybe because of that, we need to represent the segment slightly differently. So that's what I'm thinking, chat. I think we need to represent the segment slightly differently. Welcome back, Outline. So, segment 2 is going to be something like the beginning of this segment, where it begins, direction of the segment, right? Its direction, and the amount of steps at the beginning of the segment, right? So that's what it is. So if we refactor the segment to be this triple, I think we could potentially succeed in game industry. I think that could be the thing. So, and because of that, we don't really need all of that board nonsense, but we do need cell. I think I'm going to keep the cell. And what's interesting is that that solution with the new definition of a segment, right? If you have a new definition of a segment, that solution will also work for the part 1, which is kind of cool, right? Which is kind of cool. Okay, so I want to go and refactor things a little bit. So I'm going to replace segments in the places where it makes sense. So I mean, instead of segments, we're going to have like cell. So here are the cells, and this is going to be a cell. Do we need anything else? Okay. This is a still day 3. Yes, yes. Okay. So I want to commit everything we have right now because I'm kind of like afraid to lose this solution because I'm going to extensively refactor in it. So let me double check if part 2 still works. So it's going to be input. So, excuse me. Oh, you have to read the input first. Why are you still day 3? Because I'm stupid, I'm sorry. Okay, so here is that, and then I can pipe a part 1 into it, and that should give me that. Alright, let's go. So it's gonna be add day 3 part 1 solution. Okay, I'm gonna push that right into the repo. So check out the source code. So this is the source code of the part 1. So I committed because I'm gonna do like a very major refactoring of this entire thing, and I'm just afraid that something may go like really, really wrong. So we're gonna have type, and we're gonna have a segment as a new, completely new thing. So a segment is a triple cell with the beginning of the segment, right? The beginning, the amount of steps in the segment so far. And the direction, right? So this is going to be our new segment, and now I'm going to go through all the places where we use segments, and I have to change the implementations. We'll see how it goes. To be fair, I'd like to... it's going to be so painful. Okay, so not in the scope whore. Okay, 22. Yep. This one is interesting. This one is interesting. To be fair. Okay, so now you have these two segments, right? Now we have these two segments. So we have the cell of the first one, right? Cell of the first one. Cell of the second one. And intersection, by the way, intersection should give you cell plus the steps. And we can introduce like a alias for steps as well. Steps. So amount of steps, and this is going to be steps as well. Cool. So two segments, maybe, and cell, and the amount of steps intersecting these two steps and stuff like that. All right, and you have two like directions in the shit, I would say. So you can have something like dir 1, dir 2, and of course you can have steps 1, and steps 2, and this is going to be like the final thing that we're optimizing for. And we can actually use something like move 2, right? We do have move 2, which takes a cell and direction and moves the cell in that particular direction, right? And that gives us two that gives us two segments or something like that. Because of that, I think these two cells could be called begin 1 and begin 2, because we can now introduce end 1, which is move 2, begin 1, dir 1, right? You see what I mean? And 2. Okay, so we have begin and end of these two things. A begin and end of these two things. But then we have to be a little bit careful with all of that. So we know that they are sort of orthogonal. And this is the thing we have to constantly keep in mind. So the logic of these two segments becomes kind of complicated in my opinion, but okay. Russians in the chat, yeah. Comparing these like old segments was so easy. Maybe I'm gonna keep the original segment implementation then. You know what? I think it's kind of interesting idea. What if I keep the original segment implementation? So we're gonna have like two kinds of segments then. You see what I mean? So basically, segment with horizontal, vertical, and the segments that actually keep track of the cell as well. So, and you will be able to easily you can actually quite easily convert between them if you think about it. You just literally convert between them. But the problem is that if I'm going to introduce the second kind of a segment, I need to come up with a name for it, right? So I need to come up for the name for it. But to be fair, this is not really a segment. Or is it? It is a segment. It is a segment. It's just like represented differently. So, and yeah, so we will actually go into the problem how I'm gonna call. So I have two representations of the segments. So how I'm gonna call them? Segment 1 and segment 2. So segment is just can be horizontal or vertical thing here, or segment also can be one of these things. If I have all cells cached, what do BFS then? What are you talking about? What are you even talking about? Okay. So, yeah, you can find the intersection point. So you can find the intersection point of this thing. And that means you know the, yeah, so we do need both of the representations. That's the problem. We do need both of the representations. Okay. So, but I'm a little bit tired. So let's really make a cup of tea right now. Let's really make a cup of tea. Does anyone have any questions? Maybe. So let me. Everything's okay. Yeah, I do need a cup of tea. Everything's okay. I almost dropped the piston for the stuff on that. Day 3, as far as I know. I'm not sure what is the task, but I overlay with beat mask. Classic. Trying to help without understanding the problem. Don't worry, you're 99% of the chat. So what's the best way to learn Haskell? Just like any programming language, just program it. That's the best way to learn Haskell. Okay. So did it actually revert the file? Did it actually revert the file? Yeah, it didn't revert it. So this is a segment. And we need a segment 2, but I don't want to call it segment 2. If anyone could tell me how should I call this type, I would really appreciate that. So it's a cell, then amount of steps, type steps integer, and the direction. Are you gonna be drinking today? I don't drink alcohol. I'm gonna be drinking tea. vector. Not bad. Because it has a direction. Not bad, not bad. I like it. Trajectory. It has nothing to do with the trajectory. Yeah, that's. But I mean, yeah. Yeah, vector is good. I like it. Vector is good. Okay, so I'm gonna make the gut-coder move, and now this function is gonna be called intersegs. Yes. Yes. No. Because this is a very important function, trust me. Because now we're gonna have inter vectors, right? Which accepts two vectors and can return you maybe a cell plus the steps. Intervex. Yeah, that's actually cool. Thank you. Intervex. Cool. Intervex, and this is going to be vec1, vec2. Okay, it's not implemented yet, but the idea is we need a function vec2seg, vec2seg, which accepts a vec, which accepts a vec and returns you, guess what, a seg. How are we going to do that? So begin. We don't care about steps and direction, so essentially it just moves to begin to a particular direction. So there we go, we have vec2seg, and then you can do intersegs, vec2seg, vec1, and then the vec2, and that gives you the intersection of the segments at a particular point, maybe. What's interesting is that it returns you maybe, and you return maybe here as well, which enables us with using a do notation. You thought do notation is only useful for IO monads? No, you can actually use it with maybes, and it's actually pretty convenient, not gonna lie. So, and you get the end of it. So yeah, that's actually kind of cool. So we can also introduce the following thing, where we have begin 1 and this, and then begin 2, right? And now, so that's what essentially we have here. We have two begins of two vectors, and we know where exactly these two vectors intersect. Fuck yeah. So, and that's actually extremely fucking cool, because the amount of steps, right, the amount of steps that you need to take is the distance of these vectors. Holy fuck. So we need some sort of like a distance, cell dist. So you take two cells and it will give you a distance, right? So we're gonna do cell dist from begin 1 to the end, and then we're gonna do it like this. So this is the first one. So another thing we need here, actually, do we need a direction? So this is the steps 1, steps 2, right? So, and cell distance steps 1 plus, right? And what is the sum? So it has to be a sum of the sum of both wire steps. Cool. So that means it's going to be like this: steps 1 plus steps 2 plus cell distance begin to end. So that's the result, and there we go. So this is how we can approach that. Why is it so loud? Oh, holy shit, I'm sorry, it was too loud. It's not supposed to be this loud. Sorry. So we only need to implement cell dist. Alright. You see what I mean? So we now have vex, we have stuff like that. Inter, so where's inter? Inter vex. But I didn't change the definition. Expected vex. What's the precedence of plus plus? It works correctly. Don't worry about it. Okay. Couldn't match type with seg. Okay. Yeah, okay, that's true. So, yeah. So, and how do we use all of that? Yeah, so essentially now I have to do begin and make seg. So this is what we have to do here. And I don't know Haskell very well, so don't worry about it. I'm telling you, don't worry about it, it works well. Don't even worry about it. It's a correct thing. Please don't distract me. So, couldn't match seg with actual cell seg. It's kind of strange. So, make seg. Oh, it accepts a pair. It accepts a pair, so that's what we have to do here. Okay, so why do I have so many errors? I didn't even break anything, did I? Oh, okay, because this has to be as the intersection, right? So this is gonna be steps, the final steps. Like, I just don't understand why do I have so many errors. Like, I literally didn't really do much with the previous code. Okay, so inters. It has to be segs. Okay. That's probably why. Okay, finally it works. Like, I was trying not to touch the old code, but it got broke anyway. Thank you for your support. Okay, so distance between the cells, right? So you have two cells and you need to calculate the distance. I don't want to use a SQRT or anything like that. Right, so it's going to be x, y, 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 x2, y2. All right, and here's an interesting thing. We know, we know that the cells are on the same level, right? They are on the same level. Which means what we need to do here is just a taxi cab distance. Do I already have this? Okay, I only have it here. That's cool. So basically I need to just subtract them at some point. Cell distance begin. I need to define an operation on a cell. I need to define an operation on a cell somehow. Because I cannot take two cells and subtract them. Right, I cannot do that, so I need to define it somehow. So how are we gonna define it? We can define something like this. Right. And it's gonna be x1, y1, x2, y2. And also, of course, you probably want to define it like this. It's going to be cell, cell, cell. And x1 minus x2, y1 minus y2. Right. Essentially, what I'm trying to do here is just take a and b, and take the distance between these two things. Should be pretty straightforward in my opinion. We might as well simplify that by applying it here, hopefully. when taking a taxi cab distance here. Since we know that they are orthogonal, right? So we know that they are orthogonal. It shouldn't be that big of a deal. So we don't need any of this shit. Cool. So that in fact compiles. That's pretty cool. So intervects. So we have two vectors, two of these vectors, and you know, we're just seeing its intersection and stuff like that. Whether it even has an intersection, who knows? All right. So now I can parse a wire into a segment. So this is not particularly useful in my opinion. So I can parse the direction, but I want to also parse a wire, and I want it to be something like dir. So, and I will need to call SIGs of wire myself. 86 parse wire, SIGs of wire. Yeah. So this is actually a better way of doing that. I think this is a better way of doing that. Okay, and it has to be called 2 times 6 of wire. To be fair, to make the input more general, we have to, I think, accept, like, return these two things and call SIGs of wire outside. Yeah. Oh, that's very strange. Oh, this is because, okay. Part 1 accepts these two things. Yeah. So let's call it like this. It's gonna be dir. And this is gonna be segs of wire. Segs of wire. Cool. Nice. I did it. So I refactored everything. Everything is usable now. I have segs of wire, and I need vecs of wire. So I take the directions, and I wanna have vec. So this one is very interesting now. This one is very interesting. So it's a segs of wire, vecs of wire. Dirs, and what do we have here? So we have points. We can also like follow these points as well. We can follow these points as well, but I'm not sure how useful that would be. All right, how useful that would be. So the first sort of like the first point is it has to be 0 and everything. So yeah, we'll need to think about that. So I basically need to follow this entire thing, right? I need to follow this entire thing, and yeah, maybe that's the way I can go about it. That's the way. So essentially I have all of the points, and I can just zip them together, zip with. So here are the points, and how we're zipping them together. So this is a point, and I can turn it into a vector. Vector has a position, right? It has a position. Then what does it have? What does it have? It also needs the steps. I don't know how to get the steps. I don't know how to get the steps. The step is going to be that. And we also need the direction, and here are the directions. So that means this thing is going to be like a dir. So the only thing we have to keep track of here is the steps, which makes it kind of difficult to do, I suppose, but maybe not. We need to keep track of the steps. We need to keep track of the steps. We can keep track of them here, I suppose. So this is going to be the point, and here it's going to be an amount of steps, right? And in here, what do we have here? We have the point at the begin, the steps, right? And so this is the initial thing. We need end. It's essentially move to, begin move to. This has to be a direction, to a particular direction. So this is the end, right? And then what we're essentially returning essentially returning is the end Oh, I see. I see. Do we have zip3? I don't remember that we do have zip3. So tail ps. So that gives us begin and end. But it doesn't keep track of the values. It doesn't keep track of the values. We need another thing here. So, yeah, let's put it undefined. So here we keep track of the steps of points, and here we need to keep track of these steps. So how can we do that? We can do it by doing something like zip with, maybe just zip ps and tail ps, zip tail ps and tail ps, then scan L of this entire thing yet again, but the initial state is going to be 0, so because this is the steps, right? This is the steps. Okay, so this is the steps, and now what are we doing? It gives us the begin and the end. Begin, the end, and these steps. Right, the current steps. The begin, the end, and the current steps. And essentially what we're doing, we're trying to... So am I doing distance correctly? I just realized that here I'm doing distance incorrectly. I think it has to be like this. End. So if we have an end, it has to be like this. Vex to wire, and that means I can do end minus begin, take the distance and add it to the steps. There we go. Alright, so that is only this thing, so that means I'll have to move further, don't I? Excuse me. Oh, steps has to be this thing. There we go. That was not enough. Distance expects. Okay, so the end and begin. We're zipping these two things together. And then starting with that. Where am I missing anything? 76. What do you expect? I couldn't match type with an actual type. This is not true, because steps is... What am... wait. I'm getting really tired. There we go. Oh. Okay, so what else do we have here? So we need to zip this entire thing, zip 3. So points, steps, direction. That's it. That should be it. So according to the vector, it is, what is the vector? Steps, direction. Okay. Vex of y. Points, steps, direction. There we go. That should be it. Fuck. Why didn't it work? Actually, zip 3. It has to be zip 3. There we go, it works. So now we're capable of taking the list of directions, right? And turn it into a list of vectors according to my calculations, right? So that's gonna be it. That's gonna be it. Holy shit. That's actually pretty cool. So we're ready to do part 2, I think. So by the way, part 1. Yeah, part 1 takes that thing, which is nice. Part 2. it also accepts the input, like basically a pairs of these things. Okay, so inters. So we have a function inters which takes two wires of segments and just does this thing. So I need to rename it as well. So inters. So it uses inters segs. I cannot call this thing inters as segs, which is, it's kind of dumb. Let's call it all segs inters. I think that's a better name. All vex inters. So it accepts the vex, right? And it will return you. Do we really need the positions? I don't think we need the positions. I don't think we need them. Oh, by the way, I haven't tested if it even works correctly. Right, so let's actually read the input. Read the input from some sort of a sample. Sample 01. So here's the sample 01, and if I try to do, let's extract only the first one. It's going to be FST. So here's the first one, and then we're going to have segs of actually vex of wire. Let's test segs of wire. So they do work correctly. What about vex of wire? And do they increase this step? Okay, steps are increasing. We can clearly see that the steps are increasing, which is super nice. We can even confirm that, I suppose. So it's going to be something like this. So, yep. So steps are in fact increasing throughout the vector, which is super nice. I really, really appreciate that fact. Okay. So, and let's implement all vex inters. All right. So we accept what? Vec. And we only care about the steps, right? We only care about the steps. So maybe I'm gonna only return integers then. The fewest steps the wires must take to reach an intersection. The fewest. Okay, that sounds cool. So we can just return steps in this particular case. Yeah, there are steps. So here's the x's and y's, and we're again iterating through all of them, right? We're iterating through all of them, and instead of doing intersegs, we're doing intervex, x and y. Cool. And that, if I remember correctly, intervex also can return maybe, so that means we'll have to do cut maybes to get rid of them. And we only care about the step part, right? We only care about the step part, so we're gonna map all of that with SMD, right? I think that's what gives us the steps. I think that's what gives us the steps. So is it gonna recompile? No, because I shouldn't use this here. Cool. I think we're ready to do part one. Part one is actually very similar. Part two is very similar to part one. It just uses different representations. Yeah, it's kind of interesting. It's just like a different representation of a vector. That's kind of surprising to me. Part two, a bunch of like wires. And the result is going to be just an integer, right? So the result is going to be, oh, in this case, it has to be steps. Would you look at that? It has to be steps. But it's, I mean, it's integer anyway, so who cares? All right. So we do all vex inters. Then we do vex of y, x's, and vex of y, y's. And we have all of the intersections here, which is kind of cool. So we're sorting everything, and it's actually the same thing. Then it's going to be filter greater than 0, and then we're trying to take the head. I guess that's it. Is that it? That's fucking it. Changed from int representation to vec. Excuse me. All right. Okay. You know what I want to do? I want to do well, it doesn't matter. Whatever. So we need a bunch of samples. So these samples are the same. Really? Is that how it works? Wait, you can pattern match in this section of the list comprehension? I didn't know you can pattern match here. Wait a fucking second. List comprehension pattern matching. I didn't know that you can do that. Holy shit. That is so useful. It doesn't sound right, to be fair. So if you have something like just one, nothing, just two, right? So, and you're iterating through this entire thing, and then you're doing something like this, right? And if you put a pattern here, all right. Well, I remembered your nickname. Okay. I'm just a little bit scared to start doing this. 0, 1, okay? Yeah, it's a bad REPL. Yeah. Sure. It's the REPL who's wrong here. Yeah. Okay, so okay, so I'm a little bit scared. Let's read input. Well, now we're talking. Yes, something like this could be possibly working, because like you cannot put. Yeah, now we're talking. Thank you so much, non-usual. Yeah. I'm sorry, 132 Skybro, it's too late. I already remembered your nickname and I'm never listening to you ever again. Yes, that's how easy it is to lose all of your reputation. One mistake and you've mistaken. That's it. That's it. So there's nothing you can do about it. It's gonna haunt you for the rest of your life. I'm sorry. That's how it is. Yeah, don't worry about it. I'm just joking, of course. It's just nothing. Okay. So read input. That's not input sample. 1. Okay, part 1 was. This is not how we do part 1. So this is a part 1, and I think it was 159 in part 1. Yeah. What about part 2? Holy shit, it works on the sample. It works on the sample. What about the sample 2? Holy shit, it works on the sample as well. Is that a divine intellect? Chat. Shut. Is that a divine intellect? Fuck yeah, it is. Oh, fuck yeah. So, yeah, I guess I just debated myself. Yeah, so I thought that part 2 has to be solved completely differently, but I should have actually continued with the idea of the segments and stuff like that. It makes it so much fucking easy. Alright, got Cooter. Sixth first try of the stream. How about that? Isn't that amazing? 3 days in a row. 3 days in a row. Amazing. In Haskell, by the way. And also we have a cute operation here. Look at that. It's very fucking cute. So yeah. Let me see. So now we need to do a committee. Before we're gonna do a committee, I wanna actually clean up the solution and make it like a proper solution. If you know what I mean. So we're gonna do read input from the file input.txt. So this is gonna be the input, and then we're gonna do a printf. Part 1 is gonna be D. So yeah, it's gonna be D. part 1 input, and the same goes for part 2. There we go. So if I do something like that, part 1, part 2, there we go. Both of the parts are there. Alrighty, so let's actually document our solution. So what's that? Day 3 solution, and let's give the link to the day 3. And we're gonna have expected result, and it's gonna be console holo. And here are the parts. Here are the expected parts, and there we go. That's pretty cool. So we just need to come up with sets of the right types, and the code just writes itself. Add the 3 part 2 solution, and we're going to push that right into the repo, and the source code for all of the solutions is available here, right here. So far we solved 3 different days in a single stream, right? Since we don't have to worry about any spoilers, we can just keep solving them until we get tired. And yeah, that's pretty cool. So you just go to any of the folders and you just use run ghc. I want to actually confirm that it works. So for example, I want to go to 01, right, and I do run ghc main.hc, and is it going to produce something? So it loads some packages and shit like that. And it does work. So you can go to any of these things and you just run this solution, and it just solves it. And then at any point you can just take a look at the readme and ensure that this is the expected result. So here's that expected result, and here's the actual result. Cool. Yep. So yeah, that was pretty cool. Check out this repo, give it a star if you find it useful, because maybe it's useful for learning Haskell. So I'm definitely gonna add the links to the screenshot as I did for the 2020, right? Because I'm pretty sure these streams could be very educational for people who learn Haskell, right? So basically, in the previous repo, you could just click on this link and watch me solving this thing. So it's gonna be the same for 2019. All right, today's stream was actually kind of fun. I really enjoyed it, but unfortunately, boys and girls, it is time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you on the next year. Yeah, I'm 30 years old. I'm allowed to make these kind of jokes. Okay, so yeah, I'm gonna see you next year. So tomorrow we're gonna be doing a random one-off stream. So we're gonna pick a random topic, and we're gonna work on that topic for the whole stream. So also check out our schedule for more information on different projects we're working on. Check out our VODs channel, where we upload all of the VODs of these streams. This stream is going to be there, but tomorrow we upload them on the next day. For the Advent of Code 2019, we're going to have a separate playlist, so you can binge watch them if you want to, I don't know. And also check out our Discord server for offline discussion with the community. So, and yeah, that's it. Happy New Year, everyone. See you all next year. Love you. Mwah.